Hello there, and welcome to Biology with Charles, where curiosity gets cozy and science takes the scenic route to slumber. Tonight's gentle journey is about memory, that strange and selective habit your brain has of holding on to one tiny detail from 10 years ago while completely refusing to tell you where you put your keys this morning. It is one of the most familiar things in your life, and also one of the oddest. You live by it every day. You use it to know your name, your way home, the face of someone you love, the taste of coffee, the shape of your own story. And yet memory is not a perfect recording. It is not a tidy shelf of labelled boxes. It is active, picky, sometimes brilliant, sometimes completely unhelpful, and occasionally almost comical in its choices. Before we settle into all of that, I'd love to know where in the world you're listening from tonight, and what small thing you still remember for no obvious reason. Maybe it's a classroom ceiling, a smell from your grandmother's kitchen, or the exact jingle from an advert you never asked to keep forever. If you find this soothing, interesting, or simply a nice way to wind down, I'd be ever so grateful if you gave the video a like and maybe subscribed. It helps this quiet corner of science reach more people who might enjoy ending their day with a calmer kind of question. Now, get comfortable, let your thoughts loosen a little, and let's begin. Because somewhere between what stays and what slips away lies the story of how your brain decides what matters. Memory has a curious reputation. We often talk about it as though it were a storage room. We say we have a good memory or a bad one. We try to retrieve facts as if opening drawers. We speak of losing memories as if someone misplaced the folder. It is a useful way to talk, but not quite accurate. Your brain is not a filing cabinet, and remembering is not the same as reaching into a box and pulling out a complete untouched copy of the past. What your brain really does is far more complicated and, in many ways, far more impressive. From the moment you wake up, your senses are flooded with information. Light hits your eyes, sounds arrive from every direction. Your skin registers temperature, pressure, and movement. Your nose quietly samples the air. Your body tracks hunger, posture, balance, and fatigue. If your brain tried to preserve all of it with equal importance, every second in perfect detail, it would be overwhelmed almost instantly. In fact, that would not be a gift, it would be a problem. So the first important thing to understand about memory is that forgetting is not a failure of the system. Forgetting is part of how the system works. Your brain is constantly making decisions about what to hold on to, what to fade out, and what never deserves a long-term place at all. Most of the information that passes through your mind is filtered out not because your brain is lazy, but because it is efficient. It is trying to save its effort for the things that seem useful, meaningful, emotional, repeated, or surprising. That is why you can walk into a room and forget why you went there, yet still remember a teacher's odd haircut from 1998. The haircut was strange, unexpected, perhaps even funny. Your errand to the room may have been brief and unremarkable. Memory is not built simply on what happened. It is built on how your brain judged what happened. This can seem unfair, of course. There is something mildly insulting about remembering the theme tune of a cartoon from childhood, but not a colleague's name 3 seconds after being introduced. Yet from the brain's point of view, this makes a kind of sense. The cartoon tune was repeated again and again. It came with rhythm, emotion, and attention. Your colleague's name may have arrived while your mind was busy wondering whether you looked normal while saying hello. The brain is not only recording information, it is also measuring context. Was this important? Was it emotionally charged? Was it repeated? Did you focus on it? Did it connect to something you already knew? Those questions matter more than we often realize. This is why memory feels so personal. 2 people can live through the same event and remember very different things. At a family gathering, one person recalls the joke told at dinner, another remembers the argument in the kitchen, and someone else remembers nothing except the smell of roast potatoes and the fact that the dog stole a napkin. The event was shared, but attention was not, emotion was not, meaning was not. Each brain built its own version of what was worth keeping. That selectivity begins almost immediately. Before a memory becomes something stable enough to revisit later, it has to pass through several steps. First, information must be noticed. Then it has to be encoded, which is the brain's way of transforming an experience into a form it can use. Then, if conditions are right, it can be stored more durably. Later still, it has to be retrieved. At every point in that process, things can be lost, changed, strengthened, or reshaped. This is one reason memory can feel slippery. Sometimes the problem is not that a memory vanished. Sometimes it was never fully formed in the first place. Think about the last time someone told you their phone number while you were distracted. You may have heard the sounds perfectly well, but if your attention was elsewhere, the information never really got a fair chance to settle. It passed through awareness like a train through a station without stopping. Attention, in fact, is one of the most powerful influences on memory. Your brain cannot deeply encode everything at once. It has to prioritize. When you pay close attention to something, more brain resources are assigned to it. The signal becomes clearer. The experience has a better chance of sticking. When your attention is scattered, memory suffers. This is why multitasking so often produces the comforting illusion of productivity while quietly sabotaging recall. You may feel busy and efficient, but your brain is often doing a poorer job of laying down usable memories. It is a bit like trying to write notes during an earthquake. Emotion also has a remarkable effect. Highly emotional moments often stay with us more strongly than neutral ones. Fear, joy, embarrassment, grief, surprise, pride. These states tell the brain that something important may be happening. Chemicals associated with stress and arousal can strengthen the encoding of certain aspects of an event. That is why people often remember where they were during major life moments, frightening incidents, or unusually happy surprises. Emotion effectively puts the memory in bold print, but even here there is a catch. Emotional memories are not always more accurate. They are often more vivid, and vividness can feel like truth, yet a vivid memory can still contain distortions. The brain may preserve the emotional core while blurring or reshaping the details. So you may be absolutely certain about the feeling of an event while being a little less reliable about the exact sequence of who said what first. Memory is persuasive that way. It does not always tell the truth quietly. Sometimes it tells a slightly edited version with great confidence. That editing process is happening all the time. Memory is not static. Each time you recall something, you are not simply replaying a perfect original. In many cases, you are reconstructing it. You pull together fragments, emotional tone, related knowledge, and previous retellings. Then the brain rebuilds the memory in the present moment. It is efficient, but it also means memories can change. A detail suggested by someone else, a photograph viewed repeatedly, a story told at family dinners in the same way for years, all of these can shape how a memory is rebuilt. Over time, what you remember may become part original experience, part later interpretation. This is not your brain being deceptive in some malicious way. It is your brain being practical. Perfect storage would be costly. Flexible reconstruction allows the past to remain useful. Memory is not only about preserving what happened, it is also about using past experience to guide present behavior. In that sense, memory is less like a museum and more like a workshop. The materials of the past are constantly being handled, adjusted, and put to work. A great example of this comes from everyday routines. You do not consciously memorize every step of brushing your teeth, tying your shoes, or making tea. Yet you can do these things with remarkable consistency. That is because memory is not just one thing. There are different systems involved. Some memories are facts, some are events, some are skills, some are habits, some are short-lived, some become long-term, some require effort to recall, while others guide behavior quietly from the background. You may forget what you had for lunch 3 days ago, but still know how to ride a bicycle after years without trying. Different kinds of memory are handled by different networks and rules. Even in the short term, memory has limits. If someone reads you a long list of unrelated numbers, you can usually hold on to only a small amount before it starts slipping. This is part of what psychologists call working memory, the system that lets you temporarily hold and manipulate information in the mind. It is what helps you remember the beginning of a sentence while listening to the end of it, or keep a phone number in mind just long enough to type it. Working memory is useful, but it is not large. It is more like a small desk than a warehouse. Pile too much onto it, and things start sliding off. That limited capacity is one reason modern life can feel mentally noisy. Messages, notifications, tabs, tasks, reminders, fragments of news, a half-finished thought about dinner, a sudden need to reply to someone, all of that competes for the same attention and short-term holding space. The brain can cope, but not infinitely. When too many items crowd the system, some never make it farther. They vanish not because you are incapable, but because your mental desk was already covered in papers. Still, memory is not merely about limitation, it is also about remarkable creativity and efficiency. Your brain is always looking for patterns. Information that fits into an existing framework is easier to remember. That is why meaning helps. If you memorize random syllables, you will struggle more than if you learn a story, an image, or an idea that connects to what you already know. The brain likes structure. It likes relationships. It likes being able to say, this belongs with that. That is also why teaching and learning work better when facts are connected rather than isolated. A name attached to a face, a concept attached to an example, a word attached to an image, all of these have better odds of survival. The richer the network of associations, the more paths lead back to the memory later. A lone fact can go missing easily. A well-connected one has many roads home. Smell offers one of the most striking examples of how powerful those connections can be. A certain scent, sunscreen, old books, fresh bread, a particular soap can suddenly bring back a memory with surprising force. Sometimes it arrives before you can even explain it. That is because smell is deeply linked with brain regions involved in emotion and memory. A smell does not politely knock and ask whether you would like to revisit 2007. It simply opens the door and lets the old summer air in. Music can do something similar. A song from adolescence can return a whole mood, not just a fact. You may remember where you heard it, what the room looked like, the kind of person you were trying to be at the time. This is one of the lovely and inconvenient things about memory. It is not always organized by logic. Sometimes it is organized by feeling, and feeling is not known for filing things alphabetically. Of course, memory also changes across life. In childhood, the brain is developing rapidly, building vast numbers of connections, learning language, emotion, movement, and social rules all at once. Yet most adults remember surprisingly little from the earliest years of life, a phenomenon often called childhood amnesia. The infant brain is active and learning enormously, but the systems that support the kind of autobiographical memory adults later describe are still maturing. A baby can learn and remember in important ways, but not yet in the form of a detailed personal narrative like, "I was there and this happened to me on a Tuesday." As the years go on, memory becomes more organized, but also more selective. Adolescence and early adulthood often leave especially strong memory traces, partly because so many experiences are new and identity is taking shape quickly. First freedoms, first deep friendships, first major failures, first choices that feel like they matter, these tend to come with strong emotion and meaning. Later in adulthood, routines increase. That is not bad, but it does mean life can feel as if it accelerates. Familiar days generate fewer distinctive memory markers. When the brain sees another ordinary Tuesday that resembles the last 12, it may not bother making it stand out. Then, with aging, some kinds of memory may become less efficient. Retrieval can slow, names may become more elusive, new information may require more repetition. Yet older adults often retain broad knowledge, vocabulary, skills, and deep patterns of understanding extremely well. Aging does not simply erase memory, it changes its balance. Some systems weaken, others remain impressively resilient. All of this brings us back to the central puzzle. Why does your brain remember some things and forget others? The short answer is that memory is shaped by attention, emotion, repetition, meaning, context, biology, sleep, stress, and time. But the longer answer, the more interesting answer, is that memory exists to help you function, not to help you win arguments about where the blue umbrella was left 3 winters ago. It serves survival, learning, prediction, and identity. It keeps what seems useful often enough. It lets go of what seems less important often enough. It improvises. It edits. It makes a workable map rather than a perfect copy. That can be frustrating when you're standing in a supermarket unable to remember the one item you came in for. Yet it is also what allows the brain to stay flexible. Imagine carrying the full weight of every passing second forever in equal detail. Every traffic light, every cough in every waiting room, every face glanced at on every train. The world would become impossibly crowded. Thought itself might grind under the load. Selectivity is not merely a flaw, it is mercy. And still, there is something deeply moving about the things memory chooses to keep. The way a voice lingers. The way a room from childhood remains more vivid than last Tuesday. The way certain embarrassments survive with alarming freshness, while entire tax seasons disappear into a grey, administrative fog. The way your mind can lose a shopping list and preserve a single kind sentence for 20 years. Memory may not be fair, but it is revealing. It shows us what the brain noticed, what the heart responded to, what repetition carved in, and what meaning made worthy of a place. Scientists have spent decades trying to understand how this all happens in the physical tissue of the brain. How does an experience become a trace? How does a fleeting moment gain enough stability to outlast the hour, the day, even the decade? What changes in the brain when something is learned? Which structures help hold new experiences long enough for them to settle? And why do some traces strengthen while others fade almost immediately? To answer those questions, we have to move from the felt experience of memory to the machinery behind it. We have to look at what happens when a moment first enters the mind, when attention opens the gate, when the brain begins the work of turning experience into something it can keep, even if only for a while, and that is where the story starts getting wonderfully specific. A moment does not arrive in your brain as a memory. It arrives first as a flood of signals. Light patterns strike the eyes, air vibrations reach the ears, molecules brush against receptors in the nose and tongue, pressure and temperature change across the skin. Inside the body there are quieter messages too about heartbeat, breathing, hunger, tension and balance. All of it comes in at once, and almost all of it is far too much to keep. So before the brain can remember anything, it has to do something more basic. It has to sort the noise. This is one of the most important things to understand about memory. The brain is not simply recording life the way a camera records a video. A camera can point and capture whatever falls in front of the lens, but the brain is selective from the very beginning. It filters, compresses, highlights, ignores, and organizes. The moment you live is richer than the memory you later keep, and that difference starts almost immediately. Imagine walking into a kitchen in the morning. There is the sound of a kettle beginning to boil, the cool feel of the floor, the faint smell of coffee, the shape of light through the window, a half-read message on your phone, and some lingering thought about a dream that is already slipping away. Each of those details reaches the brain through a different route. Vision begins with patterns of light converted into electrical signals by the retina. Sound is translated by the inner ear into nerve impulses. Smell, touch, and taste each bring their own streams of information. The brain's first job is not to remember all of it. Its first job is to make enough sense of the scene for you to function. That early stage is often called encoding, and it is where experience begins to take a form the brain can work with. Encoding is the process by which raw sensory input becomes a mental representation. It is the first trace, the earliest step in turning a passing moment into something that might last longer than the moment itself. The keyword there is might. Most of what is encoded does not become a durable long-term memory. A vast amount of information passes through the system briefly and then disappears, rather like guests who attend the party, have one biscuit and leave without saying goodbye. Before information even reaches the point of being meaningfully encoded, it often passes through very brief sensory stores. These are sometimes called sensory memory. Visual information lingers for a fraction of a second in a form known as iconic memory. Sounds hang on slightly longer in echoic memory. These traces are extremely short-lived, but they are useful. They give the brain a brief buffer, a tiny window in which the present can be stitched together into something continuous instead of fragmented. Without that, the world might feel like a chaotic series of disconnected flashes and noises. Instead, it feels smooth. The brain is doing rapid behind-the-scenes work just to make the moment feel like a moment. But sensory traces vanish quickly unless attention steps in. Attention is the great gatekeeper. It decides what gets further processing and what gets dropped. If you are deeply absorbed in a text message, someone may say your name once, twice, even 3 times before the sound finally registers as meaningful. The ears were working perfectly well. The brain received the sound. But attention had assigned its precious resources elsewhere. On the other hand, if you are anxiously waiting for your name to be called in a crowded room, you will hear it instantly over the surrounding noise. The signal matters, so the brain treats it differently. This is why 2 people can experience the same event and come away with different memories. One noticed the awkward pause before a speech. Another noticed the joke that followed. A third spent the whole time worrying whether they had sent an email and remembers almost nothing except the shape of the exit sign. A moment is not automatically a memory. It becomes a memory partly through the narrow doorway of attention. Attention does not just decide what gets in. It also affects how deeply something is encoded. A shallow pass through attention tends to produce weak traces. You glance at a stranger's phone case on the train, register that it exists, and then never think of it again. A deeper form of attention produces more durable encoding. You meet someone new, focus on their face, repeat their name, connect it with something meaningful, and your chances of remembering improve enormously. The information is not only noticed, it is processed in a richer way. Psychologists often talk about levels of processing, and the basic idea is simple. The more deeply you think about information, the more likely it is to stick. If you see a word and only notice its font, your memory of it may be weak. If you think about what the word means, how it relates to your life, or how it compares to something you already know, the memory becomes stronger. Meaning helps, structure helps, relevance helps. The brain remembers better when it has something to do with the information besides merely letting it pass by. This is why memorizing a random list of disconnected facts can feel like trying to stack marbles on a tray, while learning through stories, images, examples, and personal connections often feels much easier. The brain likes patterns, it likes context, it likes being able to say, "This belongs here." If a new piece of information can attach itself to something already in place, it has a much better chance of surviving. A new name linked to a face, a place, a voice, and a funny detail will hold on far better than a name presented as a bare sound in isolation. Once information has passed through attention and begun to be encoded, it often enters what we call working memory. This is the mental space where information is temporarily held and manipulated. It is what allows you to remember the first half of a sentence while listening to the second half. It helps you do mental arithmetic, follow instructions, or keep an address in mind while you look for a pen. Working memory is useful, but it is limited. It is not a grand hall. It is a rather modest tabletop. This limitation matters because working memory is often where new memories either begin to strengthen or quietly vanish. If too much information arrives at once, the system gets crowded. You may try to remember a phone number while someone asks you another question. Your kettle whistles, and you realize you forgot to feed the cat. At that point, the number may leave your mind with the offended dignity of a guest who knows they are no longer appreciated. The brain can manage a lot, but not everything at once. That is one reason distraction is so unfriendly to memory formation. Rehearsal can help at this stage. If you repeat a piece of information, say a number, a name, or a direction, you keep it active in working memory a little longer. This increases the chance that it can be processed more deeply and eventually stored more durably. But repetition alone is not always enough. Anyone who has read the same paragraph 3 times while tired knows that words can be repeated without truly entering the mind. Repetition works best when it is tied to understanding and attention. The brain is not impressed by empty chanting. It prefers to know why something matters. At the level of brain tissue, all of this depends on networks of neurons communicating with one another. Neurons are the cells that send signals through electrical and chemical means. They do not store memories the way drawers store socks. Instead, memories are thought to depend on patterns of activity and connection across networks of neurons. When an experience is encoded, groups of neurons fire together in particular ways. If that pattern is important enough or repeated enough, the connections between those neurons can change. This ability of the brain to change with experience is called plasticity. It is one of the great marvels of the nervous system. The brain is not fixed in the way stone is fixed. It is dynamic. Experience can alter the strength of synapses, which are the junctions where neurons communicate. Some pathways become more efficient, some become more responsive, some grow stronger with use. In very broad terms, learning changes the brain by changing how easily certain cells influence one another. One phrase often mentioned in this context is, "Neurons that fire together wire together." It is a catchy summary, and while it simplifies a great deal, it captures something important. When 2 neurons are repeatedly active at the same time, the connection between them can strengthen. This is one of the cellular principles behind learning and memory. If a particular pattern of activity keeps recurring, the brain treats it less like a random event and more like something worth preparing for. A major process involved here is long-term potentiation, often shortened to LTP. This refers to a lasting increase in the strength of communication between neurons after repeated activation. Scientists have studied it extensively, especially in brain areas crucial for memory. If one neuron repeatedly helps activate another, the receiving neuron may become more responsive in future. More receptors may be involved. Chemical signals may become more effective. The pathway becomes easier to use. It is as though the route through the forest gets clearer every time it is walked. This is not the whole story of memory, but it is a central part of how fleeting experience begins to leave a biological mark. The first trace is not some mysterious ghostly imprint floating above the brain. It is rooted in physical change. A memory begins, at least in part, because experience alters the probability that certain neural patterns will happen again. The brain is changed by what passes through it. Emotion can intensify this process. When something is emotionally significant, the brain pays special attention. If you touch a hot pan, receive startling news, hear a baby laugh unexpectedly, or nearly trip down the stairs while carrying tea and dignity, the emotional systems of the brain become involved. One especially important structure here is the amygdala, which helps process emotional significance, particularly fear and threat, but also other emotionally charged states. When emotion is high, stress hormones and arousal-related chemicals can influence memory encoding, often making the experience more likely to stick. This is useful from an evolutionary point of view. An organism that remembers danger has an advantage. If a particular sound, place, or event predicts harm, it helps to encode it strongly. But emotion is not only about survival in the dramatic sense. Positive emotion matters too. Delight, surprise, affection, pride, embarrassment, all of these can strengthen a memory. The brain is paying attention not just to what happened, but to whether what happened matters for future behaviour. This is why ordinary days often blur while unusual ones stand out. A perfectly average Tuesday may contain hundreds of small experiences, yet few are encoded in a distinctive way. By contrast, a day involving travel, celebration, a mistake in public, or some unexpected event often leaves stronger traces because attention is heightened, emotion is engaged, and novelty is present. Novelty itself is a powerful ingredient. The brain is especially alert to what is new. Familiar patterns can be processed efficiently, but novelty suggests that updating may be required. Even so, strong encoding is not the same as permanent storage. At first, many memories are fragile. They can be disrupted, forgotten, or lost if not stabilized. This is where consolidation begins to matter. Consolidation is the process by which recently encoded information becomes more stable over time. It is one reason why a memory often needs more than a single encounter to become durable. A fact heard once may fade quickly. A concept revisited, practiced, and connected to other knowledge has a much better chance of remaining. During this early period, a region deep in the brain called the hippocampus plays a crucial role. It does not store every memory forever in the way people sometimes imagine, but it is deeply involved in forming new episodic memories, the memories of events and experiences that happen to you. If you think of the cortex as the vast outer landscape of the brain, where different kinds of information are represented, the hippocampus acts a bit like an organizer, binding together elements of an experience that were processed in different places. The sound of the kettle, the light in the window, the feeling of worry, the sight of the mug, all of those features are handled by distributed systems. The hippocampus helps link them into a coherent episode. That linking is essential. A memory is rarely one single unit stored in one single location. It is more like a coordinated pattern spread across networks. The colour of a room, the sound of a voice, the meaning of words, the emotional tone, the movement of your body. These are not all handled in the same tiny patch of tissue. Forming a memory means integrating them. The hippocampus is especially important for that integration, particularly when an event is new. This is also why damage to the hippocampus can produce such specific memory problems. A person may still remember older facts, still speak, still move, still have personality and skills, yet struggle to form new lasting memories of ongoing experiences. The machinery of consciousness remains active, but the ability to bind the present into a future memory is badly impaired. It is one of the clearest reminders that memory is an active construction process, not a passive recording. Timing matters here as well. Memories are not all formed at the same speed or in the same way. Some aspects of an experience may be captured quickly, others require repetition or reflection. If you study a concept and then explain it in your own words, sleep on it, revisit it the next day and apply it later, you have given the brain multiple opportunities to strengthen and organize the trace. If you glance at it once while checking 5 other things, the first trace may be too weak to survive. The difference between those two outcomes is not a matter of virtue. It is a matter of how the brain builds stability. Sleep, though we will come to it properly later, already deserves a quiet mention here because it plays a surprisingly large role in what happens to fresh traces. During sleep, especially certain stages of it, the brain appears to reactivate patterns related to recent experience. This may help consolidate memories, strengthening some and discarding others. It is one reason a tired brain learns poorly, and a rested brain remembers better. Sleep is not a pause in the story of memory. It is part of the machinery. Stress complicates things further. A little arousal can help memory by sharpening attention. Too much stress can do the opposite, especially if it becomes chronic. When the brain is overwhelmed, encoding can become patchy. You may remember the emotional intensity of a stressful moment but fail to remember practical details. Or your working memory may simply function less well under pressure, making it harder to hold and process incoming information. The relationship between stress and memory is not neat. It is more like seasoning and cooking. A little can bring things out. Too much ruins the dish. All of this means that the first trace of memory is not a single magical event, but a sequence of conditions coming together. Sensory input arrives, attention selects, working memory holds, meaning deepens, emotion tags importance, neurons change how they communicate, networks become more likely to reactivate in similar patterns. The hippocampus helps bind the pieces. Sleep and time begin the work of stabilization. What starts as a passing moment becomes a trace, then a fragile memory, and perhaps, with the right reinforcement, something lasting. And perhaps the strangest part is how ordinary this all feels from the inside. You do not sense your synapses changing when you remember a face. You do not feel your hippocampus binding together the sights and sounds of a rainy afternoon. You simply notice later that something remains. A room, a sentence, a smell, a detail that outlived the hour. The brain performs staggering acts of transformation and then presents you with the result so casually that it seems almost natural. Of course I remember that song. Of course I know this street. Of course that moment stayed. Yet beneath that ease lies an enormous amount of invisible work. This is why memory can be so surprising. Sometimes the first trace is strong at once, stamped in by emotional shock. Sometimes it is faint at first and only becomes durable through repetition. Sometimes it never quite forms because attention was elsewhere, and the brain did not judge the moment worthy of special effort. The difference between what stays and what slips is already beginning here, in the first contact between experience and the systems built to sort it. And once that first trace exists, another question emerges. Why do some moments get that chance while others hardly register at all? Why does one face, one sentence, one detail pass through the gate and settle in, while 10 others vanish before the day is done? To understand that, we have to look more closely at the thing quietly deciding second by second what deserves a place in the mind and what does not. If the brain had to do one job all day long besides keeping you upright and mildly functional, it would be deciding what deserves your notice. That may not sound glamorous, but it is one of the most important jobs it has. At every moment, more information is arriving than you could possibly process in full. Sounds, sights, thoughts, body sensations, background worries, fragments of language, the feel of clothing on skin, the awareness of temperature, the half-heard movement outside, the memory of something you forgot to reply to, all of it competing for space. If the mind tried to treat each signal as equally important, life would feel less like conscious experience and more like being trapped in a room with 50 radios on at once. So the brain filters, it selects, it lets some things forward and leaves others at the edge. That filtering process is what we call attention. And when it comes to memory, attention is not just helpful, it is the gatekeeper. A moment cannot become a strong memory unless it is given enough mental priority to be processed in the first place. This is one of the great reasons memory feels so unfair. We often assume forgetting means something was lost after it entered the system. Quite often, it never got in properly at all. The moment passed by, the senses registered it, but attention never opened the gate wide enough for the brain to build a durable trace. In that sense, many forgotten things were not really forgotten. They were barely admitted. Think about how often this happens in ordinary life. Someone introduces themselves at a gathering, and within seconds their name has drifted out of reach. It is not always because you have a bad memory for names. More often, your attention was already busy. Perhaps you were thinking about what to say next. Perhaps you were distracted by the noise of the room. Perhaps you were worried that your handshake felt strangely formal. The name arrived, certainly, but it did not arrive alone. It had to compete with everything else already moving through the mind, and competition is rarely kind to delicate new information. By contrast, if the same person says something unusual, or reminds you of someone you know, or arrives at a moment when your mind is calm and ready, the name may stick far more easily. The difference is not that the second name was inherently more memorable. The difference is that attention was available to receive it. Memory begins with selection. Attention itself is not one single thing. It is a collection of processes that help the brain direct resources. Sometimes attention is deliberate. You choose to focus on a book, a face, a sentence, a map. Other times it is grabbed automatically. A loud crash outside the window, a sudden movement in the corner of your eye, the sound of your own name across a crowded room. The brain is built to respond to both kinds. One helps you pursue goals, the other helps you survive surprises. In daily life, memory is shaped by the constant negotiation between what you want to focus on and what the world insists you notice. This explains why novelty is so powerful. The brain is especially alert to things that break expectation. If you walk the same route to work every day, most of it becomes background. The pavement, the familiar shop front, the bus stop, the tree with the slightly lopsided branches, none of it demands much attention anymore. Then one morning a horse is standing outside the bakery. Now attention wakes up immediately. The scene violates the script. It is unusual. It matters, or at least it might. That event has a far better chance of becoming a lasting memory than the 97 entirely standard mornings that came before it. The horse did not merely exist. It interrupted prediction, and the brain pays for that kind of interruption with attention. Expectation plays a larger role in memory than we often realize. The brain is constantly making quiet predictions about what comes next. Most of perception is not passive reception. It is active anticipation. That means routine experiences can pass with minimal conscious effort because the brain already has a model for them. Useful, efficient, and excellent for getting through the week. But efficiency has a price. Familiar moments are processed more lightly. They may be handled well enough for action, yet leave weak memory traces. Distinct moments, on the other hand, demand more attention because they do not fit as neatly into the model. They're expensive, mentally speaking, and that extra cost often buys better recall. Emotion works alongside attention in much the same way. A moment tied to embarrassment, fear, delight, anger, or surprise is more likely to recruit attention strongly. Emotion tells the brain that the stakes may be higher. If you spill coffee over yourself during a quiet morning alone, you will remember it one way. If you spill coffee over yourself in a room full of people 5 seconds before speaking into a microphone, the event will probably receive a far more energetic internal spotlight. The same basic action, very different attentional treatment. Emotion sharpens relevance, and relevance invites memory. Still, attention is limited. This is perhaps the most important fact of all. The mind feels rich and open, but its focused processing capacity is modest. You cannot truly attend to everything at once. You can switch quickly. You can divide effort to some extent. You can create the impression of doing many things. But when it comes to building strong memory traces, divided attention is often an elegant way of doing several things badly. Multitasking is especially famous for producing this result. People often feel efficient while jumping between tasks, yet the brain is paying a cost each time it redirects attention. Information is handled more shallowly, context has to be rebuilt, and memory suffers. This is easy to observe in daily life. Read a message while half listening to a podcast and stirring a pan, and you may later realize you remember almost none of the message, almost none of the podcast, and only vaguely whether the pan was meant to contain onions or regret. The tasks may all have been technically performed, but the attentional depth given to each was thin. Memory prefers depth. It prefers one thing properly handled over 3 things politely glanced at. The reason depth matters is that attention does more than highlight information. It changes how thoroughly that information is processed. A fleeting glance can register that something exists. A focused moment can link it to meaning, context, and prior knowledge. That deeper processing gives memory more material to work with. If you look at a word and only notice its shape, the trace may be weak. If you think about what it means, imagine an example, connect it to something in your own life, or explain it in your own words, the trace becomes far stronger. Attention is the first invitation. Elaborative processing is what turns the visit into a lasting relationship. This is why teaching strategies built around engagement often work better than those based on passive exposure. It is not enough for information to pass in front of the eyes. The brain remembers better when it has to do something with the material. Compare two ways of learning the same idea. In one, you read the sentence quickly while thinking about dinner. In the other, you pause, make an image, relate it to something familiar, and perhaps even laugh at a ridiculous example. The second version recruits more attention, more meaning, and often more emotion. It gives the brain multiple hooks. The first may leave almost nothing behind. Attention also depends on bodily state. Fatigue narrows and weakens it. Stress can distort it. Hunger, pain, anxiety, boredom, and overload all influence what gets through the gate. A tired brain may still function, but attention becomes less stable. It drifts more easily. It struggles to sustain focus. That means memory formation becomes patchier. You may read the same paragraph 3 times because the words keep entering the eyes and leaving the mind without settling anywhere useful. This is not a moral failure. It is physiology. The brain's gate is affected by the condition of the gatekeeper. Stress is especially complicated. In moderate amounts, it can sharpen attention. A looming deadline, a challenging conversation, a difficult task that matters, these can concentrate the mind. But when stress becomes too high, attention can narrow in unhelpful ways or fracture altogether. You may fixate on one threatening detail while missing everything else. Or your mind may scatter, unable to organize the incoming flood. In both cases, memory becomes unreliable. Later, you may remember the feeling of urgency perfectly well while recalling almost nothing about what was actually said. Strong emotion and weak attention can make for vivid but incomplete memory. One of the most interesting features of attention is that it is shaped by goals. What you're trying to do determines what the brain treats as relevant. If you're looking for your friend in a crowd, faces matching certain features will stand out more. If you're hungry, food cues become more noticeable. If you're anxious about an email, your mind may keep selecting anything remotely related to work. Attention is not neutral. It is guided by needs, fears, habits, and expectations. This means memory is partly guided by them too. We often remember what served our goals in the moment, even if those goals were not especially noble or useful in retrospect. This can make memory feel selective in deeply human ways. A person in love notices certain details more than others. A worried parent hears risks more clearly than reassurances. A student before an exam suddenly sees relevant concepts everywhere while forgetting basic household tasks. The brain is always asking, sometimes consciously and often not, what matters for what I am doing right now? Attention follows that answer. Memory follows attention. Habit has a role here as well. Repeated attentional patterns shape what the brain becomes good at noticing. If you spend years attending closely to language, music, social cues, architectural details, mechanical sounds, or emotional atmospheres, those domains become more richly encoded in experience. The expert chef notices flavors that others miss. The birdwatcher hears distinctions in birdsong that pass the rest of us by. The designer notices spacing, balance, and shape in a room almost automatically. What becomes memorable often depends on what one has learned to attend to. Expertise is not only knowing more, it is perceiving differently. Children offer a fascinating example of this. A child's attention can seem wildly inconsistent, which in a sense it is, but it is also highly responsive to novelty, play, emotion, and immediate relevance. A child may fail to notice an adult's practical instruction while remembering with astonishing clarity the fact that a beetle was upside down near the path and had funny little legs. From the adult perspective, this may appear inefficient. From the child's brain, the beetle won the competition for attention. Memory is built accordingly. Adults are not so different, only more practiced at pretending they are. There is also the curious matter of what happens when attention is present in one sense but absent in another. You can look directly at something and still fail to notice it if your attention is committed elsewhere. Psychologists call one version of this inattentional blindness. It sounds dramatic, but it happens all the time. When deeply focused on one task, people can miss surprisingly obvious things in front of them. It is not that the eyes failed, it is that the mind did not grant the input meaningful processing. This should make us all a little humbler about the confidence we place in our own awareness. Seeing is not the same as attending, and attending is not the same as remembering. The same is true for hearing. Many people have had the experience of someone speaking to them while their mind is elsewhere, only for them to realize a moment later that they heard sounds but retained nothing. The sentence brushed the ear and vanished. Without attention, language often passes through consciousness like water through a sieve. By contrast, one emotionally loaded phrase, said at the right moment, can stay for decades. A single sentence spoken during grief, kindness offered during fear, a cutting remark at an already vulnerable time, all of these recruit attention fiercely and can become unforgettable. The difference lies not in the mechanics of sound, but in the meaning assigned by the mind. Meaning itself is one of attention's favourite currencies. The brain is far more likely to focus on information that seems interpretable, useful, or personally connected. This is why abstract facts often feel slippery until they are given context. A date in history may be forgotten quickly. A story about the people living through that date may stay. A random number may vanish. A number linked to your birthday, your old address, or a great disaster involving an overcharged parking machine may survive just fine. The brain likes anchors. Attention grips better when there is something to grip. This also explains why curiosity improves memory so effectively. Curiosity is not just a pleasant feeling, it changes attention. When you are curious, the mind becomes more receptive, more alert, and more willing to engage deeply with what follows. The gate opens wider. The same information presented in a dull way and in a curiosity-provoking way can have very different fates in memory. The content may be identical, the attentional state is not. The environment matters too. Modern life is full of systems designed to capture attention aggressively. Notifications, feeds, alerts, recommendations, bright symbols, moving images, little red circles carrying mild accusations, all competing for the same limited gate. This does not merely make people distracted in a general sense, it changes memory formation. Frequent interruptions prevent sustained attention, and sustained attention is one of the best friends memory has. When the brain is constantly pulled sideways, fewer experiences are processed deeply enough to become stable. Days can begin to feel oddly full yet strangely hard to recall, as though time was spent but not properly witnessed. This may be one reason so many people feel that weeks disappear in a blur. Routine already weakens distinct encoding. Add fragmentation of attention, and the effect grows stronger. The days are not empty, they are crowded. But they are crowded with brief, competing, half-processed fragments that do not consolidate into clear, memorable forms. 100 moments entered the senses. Very few are truly let in. There is, however, a gentler implication here. If attention shapes memory so powerfully, then the quality of attention we bring to life changes what life later feels like. Moments that are noticed with care are more likely to become part of the lasting record. A conversation listened to fully, a walk taken without 3 layers of distraction, a face studied with affection, a fact learned with genuine interest. These all have better odds of remaining. This does not mean every second must be lived with solemn concentration, which sounds exhausting and very bad for tea breaks. It means simply that memory favours the attended life. Mindfulness practices, for this reason, often have interesting effects on memory and subjective time. When a person deliberately pays closer attention to present sensations, thoughts, and surroundings, moments may feel richer and more distinct. The mind is less scattered, less automated. The gatekeeper is less busy waving everything through at once and more able to say, "This is here, now." Over time, such attentional habits may influence not just stress and mood, but how fully experience is encoded. A life more closely attended may become, in some sense, a life more deeply remembered. Of course, attention cannot be perfect. It was never meant to be. The brain must ignore enormous amounts of information in order to function. That selectivity is not a weakness. It is the reason thought remains manageable at all. Yet it does mean that the boundary between what becomes memorable and what slips away is drawn much earlier than we tend to imagine. Before storage, before consolidation, before recall, there is admission. There is the moment when the brain decides, often in a fraction of a second, whether this deserves resources. Some moments get through because they are new, some because they are emotional, some because they are repeated, some because they connect to goals already alive in the mind, some because they arrive when the brain is rested and ready. Others slip away because the mind was elsewhere, because the moment resembled too many others, because the system was tired, because the signal was weak, or simply because the gate was already crowded. There is no malice in this. There is only selection. And once a moment has passed that gate, once attention has marked it as worthy of deeper handling, another system must step in to do something even more delicate. The scattered pieces of experience must be gathered, linked, and held long enough for the brain to begin turning the present into something that can still be found later, and that quiet work belongs to one of memory's most important partners. Deep inside the brain, tucked within the temporal lobes on each side, sits a structure with a name that sounds faintly aquatic and, in fact, comes from the Greek word for seahorse. This is the hippocampus, and despite its modest size and surprisingly elegant shape, it plays a role in memory that is difficult to overstate. If memory were a city, the hippocampus would not be the entire place. It would not be the streets, the houses, the people, or the old photographs in drawers. It would be more like the careful clerk at the front desk, receiving the day's incoming experiences, sorting them, linking them, and deciding how to help them settle in before they are sent elsewhere. It is not the whole of memory, but for many of the things you consciously remember from your life, especially new experiences, it is one of the brain's most important temporary keepers. That word temporary matters. The hippocampus is not usually thought of as the permanent storage site for all the memories you keep across a lifetime. Instead, it is deeply involved in forming new memories and helping them become stable enough to last. When you live through a moment, the details of that moment are processed in many parts of the brain. The sights of the room, the sound of a voice, the smell of coffee, the meaning of a sentence, the feeling of your chair against your back, the emotional tone of the situation, none of these are all handled in one single place. The brain is distributed. Different regions specialize in different kinds of information. What the hippocampus does, crucially, is help bind those scattered elements into something coherent. It turns a collection of separate features into an event that belongs together. Think of the last time you met someone in a memorable setting. Perhaps it was in a noisy restaurant or on a cold platform, or in a quiet office with bad lighting and one plant trying its best. What remains of that experience later is not one simple item labelled meeting. It may include the person's face, the sound of their voice, the topic you discussed, the song playing in the background, the oddness of the weather that day, and the awkward awareness that you had no idea where to put your hands for the first 10 seconds. Those elements live in different systems. The hippocampus helps bring them into one episode, one memory of something that happened at a particular time and place, This is one of the reasons it is so closely associated with episodic memory, the kind of memory that lets you mentally revisit events from your own life. Episodic memory is different from simply knowing facts. Knowing that Paris is the capital of France is one kind of memory. Remembering the first time you visited Paris, got lost, and paid far too much for a sandwich near a famous building is another. The hippocampus is especially important for the second kind, for the binding together of lived experience into a retrievable scene. Scientists came to understand the hippocampus partly through one of the most famous cases in the history of neuroscience, a man known publicly for many years as H.M., later identified as Henry Molaison. In the 1950s, surgeons removed parts of his medial temporal lobes, including much of the hippocampus, in an attempt to treat severe epilepsy. The procedure reduced his seizures, but it also produced a devastating and revealing consequence. He could no longer form new lasting episodic memories in the normal way. He could hold a conversation. He could remember older parts of his life to some extent. He could even learn certain motor skills without consciously remembering having practiced them. But new experiences slipped away. He might meet someone, speak with them pleasantly, and then, not long after, have no memory that the meeting occurred. That case taught researchers something profound. Memory is not a single thing. Different systems are at work. The ability to learn a new skill, such as tracing a shape or improving at a simple task, can survive even when the formation of new conscious event memories is badly impaired. In other words, the brain can still change through experience without that experience becoming part of a deliberate personal record. The hippocampus is especially central for forming memories you can later bring to mind as events, facts tied to learning, and episodes with context, not for every possible form of memory. It also showed that memory formation is a process. Henry Molaison was not unable to perceive the present. He experienced the world moment by moment. What was broken was the normal pathway by which the present becomes part of the durable past. The experience arrived, but it did not stay in the usual way. That distinction is important. It reminds us that memory is not built merely by being conscious. Something active has to happen between living through a moment and being able to remember it later. The hippocampus is deeply involved in that act of conversion. One way to think about it is this. Much of the cortex, the outer layer of the brain, handles the contents of experience. Visual areas process what things look like. Auditory areas process what they sound like. Other regions contribute language, meaning, emotion, body sensation, attention, and more. The hippocampus helps create an index, a set of links, that tie those parts together. It does not necessarily store every detail itself forever, but it helps make sure the right details are connected. Later, when you retrieve the memory, the hippocampus can help reactivate the broader pattern across the cortex. It is a bit like keeping the references that allow the brain to reopen a file whose pieces are stored across many shelves. This helps explain why context is so important to memory. A memory is easier to retrieve when some part of the original pattern is present again. A smell, a place, a phrase, a certain kind of light, these can all act as cues. Why? Because memory retrieval often works by partial reactivation. One piece of the original experience can lead the brain back toward the larger pattern. The hippocampus is particularly good at this kind of relational work. It helps connect things that belong together and later helps reconstruct them from incomplete cues. That relational role is one reason the hippocampus is also closely involved in spatial memory. It helps you remember where things happened and how locations relate to one another. If you have ever moved through a building once and later found your way around it surprisingly well, or remembered where on the shelf a particular book sat, or noticed that a route feels familiar even before you can name why, the hippocampus is likely involved. Research in animals and humans has shown that it contributes to mapping space, supporting navigation, and helping organize experience by location as well as by time. Some of the most fascinating evidence for this comes from the discovery of place cells, neurons in the hippocampus that become active when an animal is in a particular location. Later work identified related systems, including grid cells in nearby regions, that seem to help the brain map space in an organised way. Taken together, these findings suggest that the hippocampus is not only binding sensory and emotional details into memory, but also helping anchor experience in where it happened. This makes sense because episodic memory is not just about content, it is about context. It is not enough to know that a thing occurred. To remember an event properly, the brain benefits from knowing where and when it belonged. The when is interesting too, because the hippocampus seems to help organise experiences in sequence. Life does not arrive as a pile of unrelated snapshots. It unfolds. One thing happened before another. The joke came after the long pause. The spill happened before the embarrassment. The music started while you were looking for the receipt, and not after you had already left the room. The hippocampus helps encode those relations. It is part of what lets you remember not just isolated details, but the structure of an event. This happened there, with that person, before this other thing. Without that binding function, experience would be much harder to store as meaningful episodes. That said, the hippocampus is not working alone, and it is not doing all of this at a constant level for every experience. Whether it engages strongly depends on attention, novelty, emotional significance, and many other factors. A routine event may receive only minimal hippocampal investment because it resembles so many others. A novel or personally important event, by contrast, is much more likely to recruit stronger encoding. Novelty matters because the brain pays special attention to what does not fit existing patterns. If you make tea in your kitchen every day, those mornings blur because the scene is familiar. If one morning you find a large peacock standing calmly outside the window, your hippocampus is more likely to get involved with unusual enthusiasm. The memory system takes novelty as a clue that something worth storing may be happening. This does not mean every unusual moment becomes a perfect memory. It means the conditions for stronger encoding are better. The hippocampus helps create the initial record, but that record is still fragile at first. New memories need time and reinforcement to become more stable. This is where consolidation begins to matter. Early on, the hippocampus is especially important for holding together the pieces of recent experience. Over time, with reactivation, rehearsal, sleep, and integration into existing knowledge, aspects of the memory can become less dependent on the hippocampus and more firmly represented across cortical networks. There are different theories about exactly how this long-term transfer and transformation work, and the details are still being studied, but the basic idea is widely accepted. The hippocampus is especially crucial at the start. It helps establish the memory and supports its retrieval while it is still fresh and dependent. Later, as the memory is consolidated, the cortex plays a larger long-term role. In that sense, the hippocampus is like a temporary keeper, one that protects and organises new experiences long enough for them to become part of the brain's broader knowledge base. Sleep appears to be one of the times when this process is especially active. During sleep, particularly during certain stages, the brain does not simply shut down and leave memories unattended. Patterns associated with recent experience may be replayed. The hippocampus and cortex appear to communicate in ways that help stabilize memory traces. Researchers have found evidence that neural activity during learning can reappear during sleep in compressed form, as if the brain is quietly rehearsing what happened earlier. It is a wonderfully practical arrangement. The body rests, the mind disengages from the outside world, and the brain gets on with some of its filing. This may help explain why sleep deprivation is so unkind to memory. When you are sleep deprived, attention suffers first, so fewer experiences are encoded well in the first place. But even the experiences that do get encoded may be less effectively consolidated later. It is a double penalty. The gatekeeper is tired, and the overnight archivist is underperforming. Anyone who has stayed up late trying to learn something difficult and then discovered the next day that their brain retained only a faint emotional memory of struggle will find this deeply unsurprising. Stress also affects the hippocampus in important ways. In the short term, moderate arousal can sharpen memory, especially when something matters. But prolonged high stress is less helpful. The hippocampus is sensitive to stress hormones such as cortisol. Under chronic stress, its functioning can be disrupted, and memory formation may become less effective. That does not mean every stressful time erases memory. In fact, stressful periods often produce vivid fragments. But the broader ability to encode and retrieve information clearly can suffer when stress becomes persistent. The brain is devoting resources to coping, vigilance, and immediate adaptation, not calmly constructing well-ordered records of your daily life. Age changes hippocampal function as well. Across the lifespan, this structure remains important, but like many parts of the brain, it can become more vulnerable with age. Some decline in certain kinds of memory, especially forming new episodic memories or recalling recent details, is linked in part to changes in hippocampal networks. At the same time, this is not a simple story of disappearance. Older adults often retain deep knowledge, language, expertise, and many personal memories very well. The memory system is broad and varied. The hippocampus matters enormously, but it is not the entire landscape. Still, its health is strongly tied to how well new experiences can be laid down. This is one reason conditions such as Alzheimer's disease are so devastating in their early effects on memory. The hippocampus and nearby regions are often among the first areas affected, which helps explain why forming new memories becomes difficult early on. A person may still retain older aspects of identity and knowledge while struggling with recent events, repeated questions, or the continuity of the present. The temporary keeper is no longer able to do its work properly, and daily experience begins to lose its ability to settle into memory. It is one of the clearest demonstrations of how essential this structure is for turning lived moments into lasting traces. Even in healthy brains, though, the hippocampus does not record life like an objective camera. It is selective and constructive. It helps bind together what was noticed, what mattered, and what was available at the time of encoding. If attention was poor, the hippocampus has less to work with. If the experience was rich with meaning and connection, it has more. If the context shifts later, retrieval may reconstruct the event using partial cues and present understanding. The hippocampus supports accurate recollection, but recollection is still a rebuilding process. That is why people can remember the same occasion differently. The hippocampus helped form their respective records, but those records were built from different attentional and emotional materials to begin with. There is also something quietly elegant about how this structure balances separation and similarity. On the one hand, the brain needs to distinguish similar events from one another. If every breakfast in your kitchen became an indistinguishable blur, memory would be of limited use. On the other hand, the brain also needs to detect patterns and common themes. The hippocampus appears to contribute to both, helping separate similar experiences when necessary, while also enabling associations between related events. Researchers sometimes talk about pattern separation and pattern completion in this context. Pattern separation helps keep similar episodes distinct. Pattern completion helps the brain reconstruct a full memory from partial input. If you smell a certain soap and are suddenly brought back to a school changing room, that is pattern completion at work. One cue reactivates a larger whole. This balancing act is delicate. Too much blending, and memories become confused. Too much separation, and the brain loses the ability to generalize. The hippocampus helps navigate this middle path. It keeps one birthday party from becoming another, while still allowing you to understand the general concept of birthday parties as recurring kinds of events. In that sense, it supports not just memory, but the organization of experience itself. It also contributes, intriguingly, to imagination and future thinking. People with hippocampal damage do not only struggle with remembering past episodes, they can also have difficulty imagining coherent, detailed future scenarios. That may seem odd at first, but it makes sense if you consider what imagining the future requires. To picture a future event, the brain often recombines elements from past experiences, places, people, objects, emotions, likely outcomes, and contextual details. The same machinery that helps construct memories of the past may also help construct simulations of possible futures. The hippocampus, then, is not only about where you have been, it also helps you assemble where you might go. This gives memory a broader purpose than mere storage. The reason the brain keeps records is not simply to preserve a museum of the past, it is to guide behavior, support planning, help avoid danger, build identity, and imagine possibilities. The hippocampus sits near the center of that project. It takes the flowing complexity of present experience and makes it usable across time. It lets the past remain available enough to inform the future. And yet, for all its importance, it remains mostly invisible to us in daily life. You do not feel it working when you recognize the cafe where you once had an uncomfortable conversation. You do not sense it binding together the smell of rain, the shape of a street corner, and the exact sentence that changed your mood. You simply notice that the memory is there, or that it is missing. The labor happens quietly. The hippocampus does not announce that it is indexing experience. It simply does the work, minute by minute, event by event, holding the present long enough that it may become part of your remembered life. When it works well, that quiet labor feels ordinary, almost effortless. You remember the holiday, the appointment, the room where you left the book, the face you met last week, the story someone told at dinner. The brain makes this seem natural, but it is the result of a remarkably delicate coordination between attention, sensory systems, emotional tagging, and hippocampal binding. A moment becomes an event becomes a trace, and a trace begins to settle. Of course, not every memory is treated equally. Some pass through the hippocampus with modest importance and fade before long. Others are marked more strongly because something about them demands extra weight. A moment of fear, a surge of joy, a sentence that wounds, a sudden piece of good news. When emotion enters the picture, memory often becomes bolder, more vivid, and harder to ignore, and that is where the next part of the story begins to press in. There are moments that seem to arrive in the mind already underlined. They do not wait politely in the queue with everything else. They step forward, clear their throat, and announce themselves as important before the rest of the brain has even finished deciding what day it is. A close call in traffic, a wedding vow spoken in a quiet room, a phone call that changes the afternoon completely. The sudden embarrassment of waving back at someone who was not actually waving at you. Some experiences pass through life lightly, leaving only a faint mark, if any at all. Others press themselves into memory with surprising force. The reason, very often, is emotion. Emotion writes in bold. It tells the brain that something about this moment may matter for survival, for learning, for social life, for future choices, or simply for the ongoing story of who you are. Fear, joy, shock, grief, delight, anger, embarrassment, awe, love, disgust, relief. All of these states do more than colour experience. They influence what the brain encodes, how strongly it encodes it, and how easily it can retrieve it later. If attention is the gatekeeper of memory, emotion is the editor who storms in and says, "This bit stays." From an evolutionary point of view, this makes excellent sense. An animal that remembers what nearly harmed it has an advantage. If a certain place, smell, face, sound, or situation once predicted danger, it is useful to keep that information readily available. If a particular kind of food caused sickness, remembering that can save trouble later. If a social event brought humiliation, the brain may store it with unusual stubbornness in hopes of helping you avoid repeating the performance. The brain is not always subtle in how it handles these lessons, but it is often trying to keep you prepared. That survival logic does not apply only to fear. Positive emotions matter too. Remembering sources of safety, affection, belonging, pleasure, and reward is just as useful in its own way. The smile of a parent, the excitement of good news, the relief of seeing someone arrive after worry, the joy of achievement, the warmth of being welcomed. These experiences help guide behavior toward what supports life, cooperation, and emotional stability. The brain does not reserve its bold marker for disasters alone. It uses it for things worth seeking as well as things worth avoiding. Still, fear and shock often leave especially strong traces because they trigger some of the fastest and oldest systems in the brain. When something startles or threatens you, the body reacts rapidly. Heart rate changes, stress hormones are released, attention narrows, the moment becomes charged. One structure especially involved here is the amygdala, a small but important region deeply linked with emotional significance, especially threat detection, but also broader emotional processing. When the amygdala becomes active during an experience, it can influence other memory systems, including the hippocampus, making the event more likely to be encoded strongly. This is why frightening moments can feel unusually vivid. People often describe near misses, accidents, arguments, or emergencies as though time slowed down and details became sharper. The feeling is striking, a falling glass, the screech of brakes, the exact look on someone's face. The odd and very unhelpful thought that now would be a ridiculous time to remember an unrelated song lyric. In such moments, the brain is operating under heightened arousal. It is prioritizing information that might matter immediately. Later, that heightened state often contributes to stronger memory. But vividness is not the same as perfect accuracy, and this is one of the most important distinctions in emotional memory. Emotion can strengthen the feeling of remembering without guaranteeing that every detail is correct. A person may be absolutely certain about where they stood during an upsetting event, what they felt, and what mattered most, while being less reliable about the precise order of smaller details. Strong emotional memories often feel trustworthy because they are intense, but intensity is not the same thing as flawless recording. The brain remembers the significance of a moment with great conviction, yet the fine print can still be reconstructed, altered, or simplified later. A useful example is the so-called flashbulb memory, the kind people often report after hearing shocking public news or experiencing major emotional events. Many individuals can vividly recall where they were, who was nearby, and what they were doing when they first heard the news of a national tragedy, a major accident, or some personally life-changing event. These memories feel as though they were frozen in crystal. Yet when scientists study them over time, they often find that although confidence remains high, details can shift. People do remember the emotional force, they do remember the broad significance. But the memory is not a photograph. It is a reconstruction anchored in powerful feeling. That may sound disappointing, but really it says something revealing about what memory is for. The brain is not trying to become a court stenographer of your life. It is trying to preserve what seems most useful. In emotional moments, the emotional meaning often matters more than exact sequencing. The brain stores, in effect, this mattered enormously, and then preserves as much associated context as it can. Sometimes that produces remarkable recall. Sometimes it produces confidence attached to a slightly edited version of the event. Human memory is sincere without being literal. Joy can work in much the same way, though it is often discussed less dramatically. A deeply happy event can become strongly encoded because it combines several ingredients memory loves: emotion, attention, novelty, and meaning. A graduation, a reunion, the birth of a child, laughter at exactly the right moment during an otherwise difficult week, even small private moments of unexpected happiness can linger for years because they carried emotional weight. Joy tells the brain that something valuable is happening. It may not trigger the same urgent survival machinery as fear, but it still marks significance. The brain notices. Interestingly, positive emotional memories are not always as sharply detailed as negative ones, at least not in the same way. Negative experiences, particularly threatening ones, often produce narrower, more focused attention. The brain zooms in on what seems critical. Positive emotions can sometimes broaden attention, making the experience feel rich, connected, and meaningful in a more expansive way. So a frightening event may leave a sharp central detail, while a joyful event may leave a fuller atmosphere. You may remember exactly the sound of the crash, but the happiness of a summer evening may be recalled as a whole texture of light, voice, warmth, and ease. Embarrassment deserves a special mention because it occupies a strange and remarkably durable corner of human memory. Many people can recall humiliating moments from years earlier with such clarity that the body appears to believe the event is happening again. A sentence said at the wrong time, a social mistake, a failed joke, a confident entrance through the wrong door. These memories persist partly because social belonging has always mattered enormously to humans. The brain treats social errors as potentially important. It wants to learn from them. Whether it needs to remind you of a minor mispronunciation from 2009 while you're trying to fall asleep is another matter entirely, but its intentions are, in a broad sense, practical. This helps explain why social emotions can be so sticky. Shame, pride, jealousy, affection, rejection, admiration, guilt. These are not small additions to life. They shape relationships, status, trust, and cooperation. A highly social species benefits from remembering what helps and harms social bonds. If fear protects the body from danger, social emotion helps protect the self from exile, conflict, and loss of connection. The brain treats both as worth remembering. Emotion also affects retrieval, not just encoding. When you're in a certain mood, memories associated with that mood can become easier to access. This is sometimes called mood-congruent memory. When you're sad, disappointments may come to mind more readily. When you're cheerful, positive memories may feel closer to the surface. It is not that the brain is being dramatic for sport, though it occasionally gives that impression. Rather, emotional state acts as a cue. It makes networks of similarly toned memories easier to activate. A gloomy mood can therefore make the past look gloomier, not because the past changed, but because the mind is pulling more heavily from one shelf than another. This has important consequences for how people interpret their lives. In anxious or depressed states, emotional memory biases can create the impression that failures, rejections, dangers, or losses are more central and frequent than they really are. Again, this is not mere pessimism in a moral sense. It is a feature of how emotion and memory interact. The present mood shapes the ease with which certain past experiences are retrieved. That can reinforce the mood itself, creating a loop. The mind says, "See, there is more evidence for this feeling," while quietly overlooking memories that do not fit the current tone. The opposite can happen too. In positive states, the brain may more readily access comforting, successful, or affectionate memories. This can help explain why the same person, across different days, may tell a very different story about their life without any facts having changed. Memory is not only a record, it is also a current selection from the record, shaped by the emotional weather of the moment. Stress hormones play an important role in all of this. During emotionally intense events, the body releases chemicals such as adrenaline and cortisol. These affect the brain's alertness and can influence how memories are formed. In moderate amounts, this system is extremely useful. It sharpens attention and signals importance. That is one reason emotionally arousing events are often remembered better than neutral ones. But there is a balance. Too little arousal and the moment may not stand out. Too much arousal, especially if overwhelming or prolonged, can impair parts of memory even while strengthening others. This is why highly stressful experiences can produce a peculiar pattern. Some elements may be remembered with striking clarity, while others are patchy or absent. A person might remember the threatening face, the door, the smell of the room, yet have difficulty recalling the sequence of conversation or peripheral details. Under intense stress, attention narrows. The brain prioritizes what appears most critical. This can be helpful in the moment, but it means the resulting memory is often uneven. Emotion highlights the center and lets the edges fade. Trauma pushes this relationship to an extreme. Traumatic memories can behave differently from ordinary emotional memories. They may be intrusive, fragmented, sensory-heavy, or difficult to place in clear narrative order. A smell, sound, or bodily sensation may trigger the memory before the person can verbally explain it. In some cases, the memory feels less like something calmly recalled and more like something the body is reliving. This reflects the fact that overwhelming emotion can affect how memories are encoded and integrated. Trauma does not simply produce stronger memory in the usual sense. It can distort the organization of memory itself. That is why traumatic experiences can be remembered and avoided at the same time. A person may know too much and not enough. Certain fragments are too vivid, while the broader story remains hard to assemble. The brain captured the alarm, the threat, the bodily urgency, yet had difficulty integrating the experience into a stable narrative. This is one of the many reasons trauma cannot be understood simply as an extreme version of ordinary remembering. It involves the interaction of stress, emotion, attention, bodily state, and memory consolidation in more disruptive ways. On the other end of the spectrum, emotionally warm repeated experiences can become deeply woven into identity without feeling dramatic at all. A child who feels safe when a parent reads at night may not remember every single evening distinctly. Yet the emotional pattern becomes part of memory in a different form. It contributes to expectation, attachment, and the sense of what closeness feels like. Not all emotional memory is about vivid events. Some of it is about repeated tone. The brain stores not just "this happened," but "this is what it is like to be with this person," or "this is what mornings feel like in this house." Emotional learning often happens quietly through accumulation. This is part of why songs, smells, and familiar places can produce such powerful emotional recall. They are often bound not just to one event, but to many repeated states. A certain perfume may not bring back only one afternoon. It may evoke a whole period of life, a relationship, a version of yourself. Emotional memory is often layered. One cue can activate years of associations all at once, which is why the result sometimes feels larger than explanation. The brain is not giving you a single file. It is opening an entire shelf. Another curious feature of emotional memory is that people often rehearse it more. Emotionally significant events are talked about, thought about, replayed, worried over, celebrated, regretted, or retold. This repeated rehearsal strengthens the memory further. After something shocking or joyful happens, people tell the story. They go over it again with friends, relatives, or themselves. Each retelling reinforces the core memory, even if it also slightly reshapes the details. Emotion gets the memory in bold. Repetition makes the ink darker. That helps explain why some emotional memories become almost too available. The brain has learned them well, revisited them often, and linked them to many cues. A person may not intend to revisit the memory, yet it arrives anyway because it has become highly accessible. This can be comforting with happy memories and deeply exhausting with painful ones. The mechanism is broadly similar. Significance drew attention. Emotion intensified encoding. Repetition strengthened access. There's also a subtle but important relationship between emotion and meaning. Not every emotional event is remembered equally. The events that endure most strongly are often those that fit into your deeper understanding of yourself or your life. A cruel remark from a stranger may sting, but a cruel remark from someone whose opinion matters may echo for years because it connects to identity. A joyful success may be pleasant, but a joyful success achieved after long effort may become unforgettable because it carries personal meaning. Emotion strengthens memory, but meaning gives it roots. That is why major transitions tend to leave deep marks. Beginnings and endings matter. First love, first grief, first independence, first serious failure, first child, first major move, final conversations, reconciliations, departures. These moments are emotional, certainly, but they are also meaningful. They change the narrative. The brain notices not only how the moment felt, but what it meant in the larger story. Memories tied to identity are rarely neutral passengers. They become part of how the self understands itself. At times, emotion can even protect a memory from the fading that routine usually produces. Ordinary neutral details from a day may disappear within hours, add strong feeling, and the moment becomes much more resistant to loss. This is one reason people can remember exactly where they were during life-changing events, but cannot remember what they had for lunch on a perfectly uneventful Wednesday last month. The lunch lacked emotional importance. The other moment announced itself as a turning point. The brain responded accordingly. Of course, this system is not perfectly fair. It would be lovely if the brain gave equal weight to every kind remark and every useful instruction, rather than preserving an awkward silence from secondary school with museum-level care. But the emotional system is not designed to be fair. It is designed to be responsive. It reacts quickly to what seems important, especially when that importance involves bodily safety, social belonging, reward, or threat. The result is a memory landscape where some moments glow brightly and others vanish almost without protest. There is, however, something deeply human in that unevenness. The things that remain are often the things that shaped us, the joyful surprises that taught us what mattered, the fears that trained caution, the shocks that divided life into before and after, the tenderness that made the world feel habitable, the embarrassments that taught restraint, or perhaps simply taught us never again to trust slippery shoes on polished floors. Emotion tells the brain what to keep close. Still, emotion alone is not enough to explain why some memories last for decades, while others, even emotional ones, soften over time. Feeling may mark a moment strongly, but what happens next matters too. A memory can be revisited, repeated, connected, practiced, and woven more tightly into the network of what you know, or it can fade at the edges despite its initial force. Emotional importance can start the process, but strengthening over time often depends on something quieter and steadier: repetition, meaning, and the brain's habit of turning what matters more than once into something built to last. Not every memory that begins strongly stays strong. Some arrive with force and then blur. Others begin almost modestly and grow more durable with time. A fact heard once may vanish by evening, while a phrase repeated over weeks becomes nearly impossible to shake loose. A skill practiced awkwardly at first can, through repetition, become something the body performs without asking permission from conscious thought. A concept that once felt obscure can become so familiar that you forget there was ever a time you did not understand it. This is one of the most important truths about memory. What matters in the first moment is not always what determines the long life of the trace. Memory is not only shaped by attention and emotion at the start, it is also shaped by return, by repetition, by meaning, by the brain's steady habit of strengthening what keeps proving useful. This may sound obvious in a practical sense. Of course you remember things you practice. Of course repetition helps. Yet the reason it helps is worth slowing down for, because it reveals something central about what memory is actually doing. The brain is not simply storing information because it happened to pass by. It is constantly making quiet judgments about value. If something appears once and never returns, the brain may treat it as disposable. If something comes back again and again, especially in a form that matters, the brain begins to assume it deserves longer residence. Repetition is evidence. It tells the nervous system this is not random. This belongs to your world. At the level of ordinary experience, this is easy to see. If someone tells you a 7-digit code once and you do not use it, it is probably gone quite soon. If you repeat it several times while typing it in, you have a better chance of holding it for a few minutes. If that code becomes your front gate number, your office entry, or the pin tied to some daily ritual, then after enough encounters it becomes surprisingly automatic. You no longer have to summon it from the mist. It appears with hardly any effort. Through repetition, the memory has become efficient. The same thing happens with names, routes, facts, languages, jokes, songs, prayers, recipes, and countless ordinary details of life. A song heard once may leave only a vague impression. Hear it 10 times, and the chorus begins to arrive uninvited. Hear it across a summer attached to emotion, friends, place, and repetition, and it may outlive entire tax years. Repetition is not glamorous, but it is one of memory's favourite tools. That said, repetition is not all equal. Merely encountering the same thing again and again is often less effective than returning to it with attention and engagement. Many students have had the experience of rereading the same paragraph so often that the words began to look decorative, while the meaning remained stubbornly absent. The eyes passed over the material. Time was spent, yet the trace stayed weak. This is because repetition helps most when it is active, varied, and meaningful. The brain does not simply count exposure. It responds to what kind of mental work happens during exposure. One useful distinction here is between maintenance rehearsal and elaborative rehearsal. Maintenance rehearsal is repetition in a simple form, keeping something active by saying it again and again. This can be useful in the short term. It helps you hold a number long enough to dial it, or keep a phrase in mind for a moment. But elaborative rehearsal goes further. It links the new information to meaning. It connects it to prior knowledge, examples, images, emotional context, or personal relevance. This deeper kind of repetition gives memory more structure to cling to. A date in history becomes easier to remember when it's tied to a story. A scientific term becomes easier to remember when it is tied to an image, a process, or a vivid example. The brain likes repetition, yes, but it especially likes repetition that builds a network. That network matters because memories are rarely strongest when they stand alone. A memory with one weak connection can be difficult to retrieve. A memory woven into many associations has multiple routes back into awareness. If you learn a new word only as a sound, it may vanish. If you learn its meaning, see it used in a sentence, connect it to another word, picture an example, and use it yourself. The trace is much harder to dislodge. It is no longer a lone visitor sitting awkwardly in the corner. It has become part of the household. This is where meaning becomes so powerful. Meaning tells the brain not just that something has repeated, but why it matters. The brain is not impressed by raw frequency alone. If it were, every repeated advertisement would become sacred knowledge. And while some jingles certainly behave as if they own the premises, most information still requires more than persistence. Meaning organizes repetition into something usable. It allows the brain to say, "This connects to what I know, to what I need, to who I am, to what I expect." That kind of connection gives repetition its real strength. Think of the difference between memorizing an isolated list of unrelated words and remembering the events of a favorite film. The film is easier, often far easier, not because it contains fewer details, but because those details are organized by meaning. Characters have motives, actions have consequences, scenes build into one another, emotion guides significance. Repetition may happen too through repeated viewing or discussion, but meaning is what lets the brain compress complexity into a coherent form. A list remains a list. A story becomes a structure. The same is true in learning. Facts that seem meaningless often feel slippery. The moment they attach to purpose, they begin to settle. A student may struggle to remember a formula until they understand what problem it solves. A musician may struggle less with theory once the patterns become audible and useful. A child may learn words more readily when they help achieve something wanted. Memory loves usefulness. It remembers better when information can do work. At the neural level, repetition changes the probability that certain pathways will activate again. Repeated activation strengthens communication between neurons involved in the same pattern. We have already touched on long-term potentiation, the process by which repeated use can strengthen synaptic connections. Repetition is one of the ways that strengthening happens. Each return to a memory or skill helps reinforce the pathway. especially if the retrieval or practice is successful. The road becomes easier to travel because it has been travelled before. This is why practice is so important for skills. The first time you perform a new motor action, it can feel stiff, conscious, and fragile. Driving a car, typing on a keyboard, pronouncing sounds in a new language, playing a chord on a guitar, using chopsticks without turning dinner into performance art, all of these may begin with deliberate effort. But with repetition, the brain refines the movements. Networks involved in coordination, timing, and habit become more efficient. What was once slow becomes smoother. What required concentration becomes easier. A memory has not simply been stored, it has been trained into fluency. There is an interesting paradox here. Repetition often makes memories stronger while making the effort of recall feel smaller. At first, remembering takes work. Later, it feels obvious. This can trick us into underestimating how much practice shaped the result. A pianist may sit at a keyboard and move with apparent ease, yet that ease is built from thousands of repetitions. A person may navigate their hometown without conscious effort, yet every turn has been laid down over years of returning. Even identity is partly shaped this way. The repeated stories you tell about yourself, the repeated habits of thought, the repeated emotional patterns you revisit, all of these become easier to access because they have been reinforced. That last point is worth pausing on. Repetition does not only strengthen facts and skills, it also strengthens interpretations. If you repeatedly think of yourself as capable, helpless, unlucky, resilient, unwanted, competent, foolish, cherished, or behind everyone else, those self-related ideas can become more accessible over time. The brain learns patterns of self-understanding partly through repetition. This is one reason why recurring criticism, recurring encouragement, and recurring internal dialogue can have such long-lasting effects. A thought returned to often enough may start to feel like a fact. Memory and meaning together help build the personal narrative. This also explains why therapy, education, parenting, and daily relationships all matter so much. They shape not only what happens, but what gets repeated and what meaning is attached to repetition. A child repeatedly told they are incapable may come to remember effort itself as futile. A child repeatedly helped through difficulty may come to remember challenge as survivable. An adult who repeatedly rehearses shame may strengthen it. An adult who repeatedly practices reframing and self-compassion may strengthen something gentler. Memory is not only built from events, it is built from repeated interpretations of events. Repetition is especially effective when spread over time rather than packed tightly into one session. This is one of the most reliable findings in memory research. Spaced repetition tends to produce stronger long-term memory than cramming. If you review information across several days or weeks, the trace usually becomes more durable than if you repeat it many times in one short burst. Part of the reason is that spaced repetition forces retrieval after some forgetting has begun. That retrieval effort itself strengthens the memory. The brain has to work to reconstruct the trace, and in doing so, it often reinforces it. By contrast, massed practice can create a comforting illusion. You see the same material repeatedly in a short period, and it begins to feel familiar. Familiarity can be pleasant, but it is not always the same as durable recall. A person may leave a long study session feeling confident simply because the material has been in view so often. Then the next day they discover that much of it has evaporated. Spacing helps because it challenges the brain to bring the memory back after some interval. That act of bringing it back is not a sign of weakness. It is one of the things that makes the memory stronger. Retrieval practice more generally is powerful for the same reason. Testing yourself, explaining a concept from memory, recalling rather than merely rereading, all of these strengthen learning better than passive review alone. The brain learns not just from putting information in, but from pulling it back out. Each successful retrieval makes the pathway easier to access in future. It also shows the brain that the information remains relevant enough to be used. Retrieval is repetition with purpose. Meaning intensifies this process. When a memory is tied to goals, relationships, identity, or emotional significance, the brain has more reason to preserve it. A medical student remembers anatomy not only because it is repeated, but because it is connected to a role, a future, a profession, a sense of importance. A parent remembers details about a child because those details matter in daily life and emotional life both. A person remembers the route to a beloved place more deeply than the route to a forgettable waiting room. Meaning acts almost like weight. It tells the system that the memory is not floating freely. It belongs somewhere central. This is one reason autobiographical memory is so uneven. You do not remember every Tuesday equally. You remember the Tuesdays that meant something, or the ones repeated into pattern. The Tuesday you moved house, the Tuesday you got engaged, the ordinary Tuesday dinners at your grandmother's home over many years, the Tuesday you received difficult news, the Tuesday you always took your child to swimming lessons. Some memories stand out because of unique meaning. Others become strong because repetition turned them into emotional landmarks through accumulation. A single event can matter. A repeated event can settle even deeper. Repeated experience can also transform the kind of memory involved. At first, an experience may depend heavily on conscious recall. Later, parts of it become more automatic, more semantic, or more habitual. For example, when learning a new route, you may initially remember it as a specific episode. Turn left at the red shop, then right at the cafe with the crooked sign. After many repetitions, you no longer remember each trip as a separate event. Instead, the knowledge becomes generalized. You simply know the route. The brain has extracted the stable pattern from repeated episodes. Repetition helps move memory from fragile specifics toward durable knowledge. A similar thing happens in language learning. At first, a phrase may be recalled with effort, tied to the exact lesson in which it was learned. Later, with repetition and use, it becomes part of your usable vocabulary. The original learning episode fades, but the knowledge remains. Memory grows stronger over time not only because individual traces are reinforced, but because repeated experience allows the brain to abstract what is stable and useful across many encounters. This abstraction is one of the brain's smartest habits. It would be wildly inefficient to store every instance of opening a door as a separate sacred event. Instead, repeated experience lets the brain learn the general principle. At the same time, if one particular door leads to an unforgettable conversation or a disastrous surprise involving paint, ladders, and misplaced confidence, that specific episode may also be retained. Memory balances the general and the particular. Repetition helps build the general, meaning often preserves the particular. There is also a social side to repetition. Memories grow stronger when they are retold. Families do this constantly. Couples do it. Friends do it. People return to shared events, rehearse favourite stories, repeat the funny mistake, the travel disaster, the holiday moment, the sentence someone always says wrong. These retellings reinforce the memory, but they also shape it. Each telling highlights certain details and leaves others behind. Over time, the repeated version may become the version most easily recalled. This is not necessarily dishonest. It is one of the normal ways memory becomes social. The past is strengthened by conversation. Sometimes the strengthening is beneficial. Repeatedly recalling joyful or meaningful experiences can help preserve them and make them easier to access in hard times. Sometimes the strengthening is less helpful. Repeatedly rehearsing painful events, regrets, grievances, or humiliations can deepen those pathways too. Rumination is, in one sense, repetition with emotional charge. The mind goes back again and again, not to learn something new, but because the pathway has become compelling. Repetition does not distinguish neatly between what helps and what harms. It strengthens what is revisited. That is why habits of thought matter so much. The brain is always learning from what it returns to. If a person repeatedly notices failure and ignores progress, that pattern becomes easier. If they repeatedly attend to threat, threat becomes more expected. If they repeatedly practice gratitude, careful observation, or compassionate reinterpretation, those too become more available. Memory is not a passive vault. It is a living system responding to use. Meaning can rescue repetition from emptiness, but repetition can also rescue meaning from fragility. A deeply meaningful moment may still fade if it is never revisited, never linked, never given further life. By contrast, even a subtle but important value can become stable when enacted repeatedly. Love is remembered not only through great declarations, but through repeated acts. Trust is learned not from one statement, but from consistency over time. Belief in one's own ability is often built not from one triumph, but from many returns to effort. The brain learns what to keep by what keeps happening, and by what those happenings come to mean. This is one reason rituals are so memorable. They combine repetition and meaning beautifully. A holiday tradition, a weekly meal, a bedtime routine, a morning walk, a prayer, a song sung in the same place each year, all of these gain power because they repeat in a meaningful frame. The brain comes to expect them, recognize them, and anchor feelings to them. Over time, they become more than the sum of their parts. They are no longer isolated events. They are memory structures, stable and emotionally charged, because repetition has turned them into landmarks. The same principle helps explain why traumatic reminders can be so strong and why comforting routines can be so regulating. A repeated association between a cue and fear can make the cue powerful. A repeated association between a cue and safety can do the same in the other direction. The nervous system learns through pairing and repetition. Meaning tells it what the pair implies. Over time, the body and mind begin to respond before thought has fully caught up. There is in all this something oddly hopeful. Weak memories are not always doomed to remain weak. Through practice, return, and connection, they can strengthen. Difficult material can become familiar. New skills can become natural. Uncertain pathways can become clear. At the same time, it also means the brain cannot keep everything equally. Strengthening one set of pathways often means allowing others to fade. Memory grows by selection as much as by accumulation. And this brings us quietly toward the next piece of the puzzle. If repetition and meaning help memory settle and strengthen, there still remains the question of when the brain does some of its most important behind-the-scenes work. Because much of this strengthening does not happen only in the bright effort of daytime attention. Some of it happens later, in quieter conditions, when the world is dimmer, the body is still, and the brain begins sorting the day with a kind of silent efficiency that most of us sleep through entirely. For something that looks so quiet from the outside, sleep is remarkably busy. You lie still, the room goes dark, the body settles, breathing slows, and from a distance it can seem as though the brain has simply stepped away from the desk, turned off the lamp, and decided to resume all serious operations in the morning. But that is not what happens at all. Sleep is not a blank stretch in which memory politely waits in the hallway for business hours to begin again. Some of the most important work memory does happens precisely when you're no longer trying to remember anything. This is one of the great reasons sleep matters so much for learning. During the day, the brain is busy taking an experience. It is listening, seeing, speaking, choosing, reacting, solving problems, worrying about messages, walking into rooms and occasionally forgetting why, all while forming the first traces of memory from the flow of ordinary life. But those fresh traces are often fragile. They are recent, incomplete, and somewhat vulnerable, like wet ink on paper. Sleep helps the brain decide what to do with them. It strengthens some, trims others, integrates certain memories with older knowledge, and in the process makes yesterday more usable tomorrow. In other words, sleep is not just rest, it is sorting. To understand why this matters, it helps to remember that not every memory is fully formed the moment it appears. During waking life, attention and encoding begin the process. The hippocampus helps bind the pieces of experience together. Neural patterns start to change. but recent memories are not yet as stable as older ones. Left unsupported, some will weaken quickly. Others will remain only if they are revisited, rehearsed, or consolidated. Sleep plays a large role in that consolidation, which is the gradual process by which new memories become more durable over time. You can think of the day as a period of collection. The brain gathers impressions, conversations, facts, emotions, names, routes, half-formed ideas, awkward moments, useful details, and the lyrics of songs you did not ask to learn but now seem fated to keep forever. At night, the system shifts from gathering to sorting. The incoming doors close, external demands quiet down, and the brain, free from the constant pressure of new sensory traffic, can spend more effort working with what has already arrived. This does not mean the brain literally watches a replay of your day like an employee reviewing security footage while drinking cold coffee. The process is more subtle and more interesting than that. During certain phases of sleep, patterns of neural activity linked to recent learning appear to be reactivated. Researchers have found evidence, especially in both animals and humans, that the brain can replay aspects of waking activity during sleep in compressed form. A rat that ran through a maze while awake shows related patterns in the hippocampus during later sleep. Human studies suggest something similar happens with recently learned material. It is as though the brain returns to fresh experiences, not to relive them exactly, but to reinforce and reorganize them. This replay is one of the reasons sleep seems to support memory so reliably. A fresh trace formed during the day may be reactivated at night, strengthening the relevant connections and helping integrate the memory into wider cortical networks. The hippocampus, which plays such an important role in holding together new episodic memories, appears to participate in this dialogue with the cortex during sleep. The recent memory is not simply stored once and forgotten about, it is revisited. That revisiting helps it settle. It also helps explain why sleep after learning is often more effective than trying to stay awake and keep pushing. People commonly assume that more waking hours must mean more opportunity to memorize, but the relationship is not so simple. A tired brain does not encode very well to begin with. Attention drifts, working memory weakens, and the first traces are shakier. Then, if sleep is delayed or reduced, consolidation suffers too. The result is a double loss. You took in the information less effectively, and then gave the brain fewer chances to stabilize what it did take in. This is one reason late-night studying can produce the very confident but tragic feeling of "I absolutely know this," right before discovering the next day that you, in fact, did not. Different stages of sleep seem to support different aspects of memory. Sleep is not a single uniform state. It unfolds in cycles, moving through stages that vary in brain activity, body state, and likely function. Broadly speaking, sleep includes non-rapid eye movement sleep, often shortened to non-REM, and rapid eye movement sleep, or REM. Both appear to contribute to memory, though perhaps in different ways. Deep non-REM sleep, particularly slow-wave sleep, is often associated with the consolidation of declarative memories, the kind involving facts and events. These are the memories that help you remember what you studied, what someone told you, what happened at dinner, or where you put something before going to bed and therefore where it absolutely ought to be in the morning, though that last category is not always guaranteed. During slow-wave sleep, the brain shows large, slow oscillations in activity, and these appear to help coordinate communication between the hippocampus and cortex. This may provide an especially useful window for transferring or stabilizing new information. REM sleep, by contrast, is often linked more strongly with emotional memory, procedural learning, and the sort of associative integration that helps the brain connect ideas in new ways. REM is the stage most associated with vivid dreaming, though dreaming can occur in other stages too. During REM, brain activity is more wake-like in some respects, yet the body remains largely still. This curious state may help the brain process emotional experiences, strengthen certain kinds of learned patterns, and integrate memories in a way that supports creativity, generalization, and flexible understanding. The distinction is not perfectly neat, and memory is not kind enough to separate itself into tidy boxes just because scientists would appreciate the gesture. But the overall picture is clear enough. Sleep stages are doing different kinds of work, and memory benefits from the whole structure of a healthy sleep cycle, rather than from one magical phase alone. This is why cutting sleep short can be more disruptive than people realize. It is not simply a matter of being groggy. When sleep is interrupted, shortened, or poor in quality, the brain may not complete the normal cycles that support memory processing. A person may spend enough total time in bed to feel they have technically participated in sleep, yet still lose some of the deeper or later phases needed for optimal consolidation. The result can be frustratingly familiar. You function, you get through the day, but names do not stick as well, learning feels heavier, details blur more quickly, and your brain begins to resemble an office where important papers are being stacked in unstable piles, because the filing system has called in sick. Sleep's role in memory also helps explain why sometimes the solution to a mental block seems to appear after a night's rest. You struggle with a concept, a sentence, a problem, or a decision. It feels tangled and stubborn in the evening. Then the next day, something about it is clearer. This is not always because the answer floated in on moonlight and wisdom. Often it is because the brain continued working in the background, integrating information, weakening irrelevant details, and strengthening useful relationships while you slept. Sleep is not conscious reasoning, but it helps prepare the mind for better reasoning later. This matters not only for schoolbook learning or professional skills, but for emotional life as well. Sleep seems to help process the emotional tone of experiences. A difficult event that feels raw in the evening may still matter in the morning, but it is sometimes less immediate, less electrically alive. Part of that may come from the brain's overnight work of reprocessing emotional memories. Healthy sleep appears to help separate the fact of an experience from the full physical force of the initial emotional reaction. You still remember what happened, but the system is not sounding the alarm at the same intensity. When sleep is disrupted, that emotional processing may be less effective. People who are sleep deprived often become more reactive, less regulated, and more likely to experience the day's difficulties as sharper or harder to manage. That in turn affects memory. Stronger unmanaged emotional responses can distort attention, interfere with encoding, and bias recall toward negative material. Sleep, then, supports memory not only by strengthening facts, but by helping emotional experiences become more integrated and less chaotic. Dreaming enters the conversation here too, though it remains one of the more mysterious features of sleep. Dreams do not seem to be direct recordings of the day, despite how often they borrow material from it. Rather, they often combine fragments of recent experience with older memories, concerns, emotions, and improbable narrative choices that would never survive a serious editorial meeting. A childhood teacher may appear in your current kitchen discussing train schedules with a former neighbour, while you search for shoes that keep becoming oranges. The brain is clearly doing something inventive, though not necessarily polite. Even if dreams are not literal memory consolidation made visible, they may reflect some of the brain's integrative work. Recent concerns and older associations become mixed. Emotionally significant material returns in altered form. Patterns are explored, not necessarily in a logical order, but in ways that may still relate to learning, adaptation, and memory processing. Dreams may be one window into a broader process in which the sleeping brain reorganizes experience, tests associations, and loosens material from strict waking logic, just enough to combine it differently. This may help explain why sleep sometimes improves creativity. After rest, people can be better at noticing connections, solving problems indirectly, or reorganizing knowledge in more flexible ways. Memory is not only about preserving the past exactly, it is also about making the past useful. A brain that can link experiences, extract patterns, and generalize from what it has learned has an enormous advantage. Sleep appears to support that kind of usefulness by helping the brain move beyond mere storage toward integration. It also seems to help with selection. Not everything you experience deserves equal preservation. Sleep may help the brain sort what is worth keeping from what can be allowed to fade. Emotion, repetition, relevance, novelty, reward, expectation, and future usefulness all likely play a role in this selection process. A fact you deeply studied, an emotionally charged event, a motor sequence you practiced, or a meaningful conversation is more likely to receive further processing than the exact pattern of tiles on a floor you crossed absent-mindedly. Sleep helps the brain act less like a warehouse and more like an intelligent editor. Of course, editors sometimes make baffling decisions. Most people have had the experience of a highly practical thing disappearing overnight, while some utterly irrelevant detail remains perfectly polished. You forget the name of the person you were just introduced to, yet can still recall the cartoon sound effect used in an advert from childhood. This is not evidence that the sleeping brain has a sense of humour, though the case remains open. It is evidence that memory prioritization depends on more than utility in the immediate adult sense. Repetition, emotional tone, attention, and associative richness all influence what gets strengthened. Sleep is especially important for children and adolescents because their brains are learning on a large scale all the time. Language, social rules, movement patterns, academic material, emotional habits, personal identity, all of it is developing and changing rapidly. Not surprisingly, poor sleep during these years can have serious consequences for learning and regulation, yet adults are no less dependent on it. The idea that only the young need sleep for memory is one of those fashionable lies people tell themselves right before forgetting why they open the fridge. Aging changes sleep too, and these changes may contribute to age-related memory difficulties. Older adults often experience lighter or more fragmented sleep, with less slow-wave sleep in some cases. That can affect consolidation, particularly for certain kinds of new learning. This does not mean that memory problems in aging are simply a matter of sleep, but sleep is certainly part of the picture. The brain's nighttime sorting systems continue to matter across the lifespan. There is also a practical lesson here for anyone trying to remember more effectively. Memory is not built only at the moment of study or experience. It is supported afterward by what happens during rest. A well-timed pause, a decent night of sleep, and repeated review across days often do more for long-term learning than one heroic bout of exhausted effort. The brain benefits from cycles. It takes in, settles, revisits, strengthens, and trims. Trying to force all memory work into the waking moment is rather like insisting the laundry should dry while still submerged in the washing machine. Quiet matters for another reason as well. Sleep reduces interference. During the day, fresh traces compete with everything that comes after them. New conversations, new tasks, new worries, new sensory input, all of these can interfere with recently encoded material. Sleep creates a period in which that competition drops dramatically. The memory has a chance to consolidate without being constantly bumped aside by the next incoming demand. It is easier to strengthen something when the hallway is no longer full of traffic. That may be why even short naps can sometimes help memory. A nap does not replace a full night of sleep, but under the right conditions it can improve retention, especially after learning. Part of the benefit may come from giving the brain an early opportunity to begin consolidation and from briefly reducing the flood of interfering input. A nap is not laziness in disguise. It is on occasion a tactical retreat in service of better neural bookkeeping. There is also something reassuring in the idea that the brain keeps working kindly after consciousness lets go. So much of waking life asks for effort. Pay attention. Try harder. Repeat that again. Focus. Do not forget. Yet part of memory's growth depends on surrendering control for a while. You do your part during the day. You notice, study, practice, care, repeat. Then sleep takes over and handles a different stage of the task. It is a partnership between conscious effort and biological maintenance. You're not solely responsible for holding the whole system together by force of will, which is fortunate, because most of us would misplace the instructions within a week. Still, the sleeping brain is selective, not sentimental. It does not preserve everything. It strengthens some traces and lets others thin out. It integrates pieces into wider knowledge. It softens certain emotional edges while reinforcing patterns that seem meaningful or repeated. By morning, something has changed. The memory is a little more stable, a little more usable, or perhaps a little more gracefully on its way to being forgotten. Silence has done work. And that quiet sorting leads us naturally toward a harder truth. If sleep helps preserve what matters, then forgetting is not merely the enemy sneaking in when the guards are tired. In many cases, forgetting is part of the design. The brain must let go of a great deal in order to stay flexible, efficient, and sane. Memories are strengthened, yes, but others are thinned, displaced, confused, or cleared aside, and to understand why your mind remembers something so well, we have to make room for the equally important question of why it releases so many others. Forgetting has a bad reputation. We talk about it as though it were evidence of decline, carelessness, weakness, or some quiet betrayal by the mind. A forgotten name feels rude. A forgotten appointment feels irresponsible. A forgotten password feels like a personal insult delivered by a machine that knows full well you typed it correctly at least once in 2022. We tend to imagine memory as the good and forgetting as the failure. But the brain does not see things so dramatically. From the brain's point of view, forgetting is not simply what happens when the system goes wrong. Quite often, forgetting is part of how the system stays useful. This is one of the hardest ideas to accept because forgetting feels so inconvenient. You want your brain to keep the thing you need exactly when you need it, without complaint. You want it to remember the person's name, the location of the document, the item on the shopping list, the date, the detail, the plan, the sentence you were about to say before someone interrupted you with a completely unrelated observation about avocados. Yet the brain is not designed to preserve every passing detail forever in equal clarity. It is designed to manage life. That means selecting, prioritizing, compressing, revising, and yes, letting go. If it did not let go, it would have a different problem entirely. Imagine remembering every ordinary detail of every ordinary day with the same vividness. Every face passed on a pavement, every receipt handled, every ceiling tile in every waiting room, every version of where you left your shoes, every sentence overheard in a shop queue, every digital password ever changed because one website insisted that a capital letter, a symbol, a number, and apparently a small act of spiritual devotion were all required. Such a system would not be superior, it would be swamped. Useful memory depends on selectivity. Forgetting is one of the prices of that selectivity, and also one of its benefits. One of the simplest explanations for forgetting is decay. The idea that memory traces can weaken over time if they are not used or reinforced. This does not mean a memory literally evaporates like steam from a cup of tea, but it does capture an important truth. Neural pathways that are not revisited tend to lose strength. If a memory is formed weakly, not repeated, not connected to much else, and not retrieved for a long period, it becomes harder to access. The trace is not always gone completely, but it may be so faint that bringing it back requires more than the mind can provide. This is easy to observe with small things. A phone number used daily becomes effortless. Stop using it for a few years, and suddenly it goes from being automatic to something you can only half recall, like a tune played through a wall. The same happens with vocabulary in a language you once studied, the name of a film you definitely loved, or the exact route to a place you visited many times before moving away. Time alone is not the only factor, but time without use often weakens the path. Still, decay is not the whole story, because many memories do not disappear simply because they sat quietly. Some are still there, stubborn and strangely polished after years of disuse. Others vanish quickly despite seeming important. That is where interference comes in, and interference may be one of the most common reasons forgetting feels so frustrating in ordinary life. Interference means that memories compete with one another. New information can make older information harder to retrieve, and older information can get in the way of new learning. The brain is not a series of isolated drawers, it is a crowded living network. Similar things overlap, related traces jostle for access. Sometimes the memory is not absent at all, it is being blocked by other memories standing in the doorway. A classic example is learning a new password right after years of using an old one. You sit down, confidently type the previous password, and the computer rejects it with cold administrative authority. You try again, perhaps a little more insistently, as though conviction itself might persuade the system. But the old memory is stronger because it has been repeated so often. The new one has not yet settled. This is called proactive interference, when old learning interferes with new learning. The previous password keeps pushing itself forward because the pathway is well worn. The reverse can happen too. After learning something new, you may find it harder to recall what came before. A person who moves house may remember the new postcode better, while the old one begins to blur. Someone who studies several similar theories in one evening may find them drifting together until the boundaries soften. That is retroactive interference, when newer material makes older material harder to retrieve. Neither memory is necessarily destroyed. They are simply competing, and the newer arrival has rearranged the furniture. Interference is especially common when memories are similar. Similar names, similar faces, similar facts, similar routines, similar locations. All of these create fertile conditions for confusion. Meet three people at once named Anna, Hannah, and something that absolutely sounded like Anna in a loud room, and your brain may not do a graceful job of sorting the results. Park in a slightly different place each day in a similar car park, and you may confidently march toward yesterday's space with the noble certainty of a person whose memory has betrayed them again. Similarity breeds competition. The brain likes patterns, but sometimes patterns overlap a little too enthusiastically. This overlap is one reason routine can make time feel like it disappears. When days resemble each other closely, the brain often encodes them less distinctly. It keeps the general pattern, but not always the particular Tuesday. You remember that you worked, answered messages, ate lunch, and probably looked for something you had just put down. But the exact details of one day are hard to isolate because they interfere with the many nearly identical days around them. The memories are not absent in a simple sense. They are densely layered, and individual access becomes difficult. Retrieval failure is another major reason forgetting happens. Sometimes the memory is stored, or at least partly stored, but the brain cannot find a workable route back to it at that moment. This is the maddening experience of knowing that you know something while being unable to produce it. A name sits just outside reach. A word hovers like an unhelpful ghost. The answer is somewhere in there, but it will not step into the light. Then later, often when you're brushing your teeth or looking for a sock, it appears on its own with infuriating ease. The memory was not lost. The retrieval cues available at the first moment were not enough. This is why context matters so much. Memory is easier to retrieve when some part of the original situation returns. A smell, a place, a tone of voice, a mood, a phrase, these can all act as keys. If you learned something in one setting and try to retrieve it in a very different setting, the path back can be weaker. Students often notice this when information seems easier to recall in the room where they studied than under the pressure of an exam hall. Everyday life offers countless milder versions. You walk into a room and forget what you intended to do, then return to the previous room and immediately remember. The shift in context removed the cue, then restored it. The brain was not mocking you personally. It was following the shape of its own associations. Emotional state can function as a retrieval cue too. When you're anxious, anxious memories often come more readily. When you're relaxed, different parts of the past may feel more available. This means forgetting can sometimes be partly state-dependent. A thought formed in one mood may be much easier to reach again in a similar mood. That is useful in some circumstances and rather inconvenient in others. It also helps explain why the mind can feel like a different archive on different days. The contents have not all changed, but the shelves nearest the front have. Then there is the simple matter of insufficient encoding. Many things are forgotten because they were never fully learned or stored in the first place. We often notice forgetting only at retrieval, so it feels as though the problem happened later. In reality, the weakness may have begun at the start. If attention was divided, if the material had no meaning, if the brain was tired or overloaded, if nothing connected the information to anything already known, the trace may have been faint from the beginning. It is difficult to retrieve what was barely encoded. This is why a name heard once in distraction vanishes so quickly. The brain did not reject it after careful storage. It simply never built a strong enough foothold. Stress complicates forgetting further. In small amounts, stress can sharpen memory for important details. In large or prolonged amounts, it often does the opposite. Chronic stress can impair attention, reduce working memory efficiency, disrupt sleep, and make new learning harder. It can also bias the brain toward threat-related material, which means neutral information may be poorly encoded while emotionally charged concerns remain more accessible. In practical terms, a stressed person may remember the feeling of pressure vividly while forgetting ordinary details around it. The mind becomes narrower, more survival-focused, and less able to form broad, stable records of daily life. Sleep deprivation produces a similar kind of trouble by a different route. When people sleep badly, they tend to encode less effectively during the day, then consolidate less effectively at night. The result is more forgetting, more blur, and more mental friction. It is no wonder a tired brain misplaces details. It had fewer resources to attend, less ability to organise, and less overnight support to stabilise what it did take in. A surprising amount of forgetting is not dramatic cognitive failure. It is simply the ordinary consequence of a brain doing demanding work without enough restoration. Forgetting also serves a functional role by preventing overload. The brain is not merely losing information by accident. It appears in many cases to actively reduce access to material that is no longer useful, or at least not useful enough to maintain at high strength. This is not usually a conscious decision, it is an economy. Strengthening one pathway often comes at the expense of others receiving less reinforcement. A memory that is rarely revisited becomes less available partly because the brain is devoting its resources elsewhere. What you keep using stays easier to use. What you stop using drifts toward the background. This is efficient. It keeps the system adaptable. There is something almost elegant in that. The brain is constantly revising its priorities. It does not cling equally to the route to an old office, the menu of a restaurant you visited once on holiday, the Wi-Fi password from a flat you moved out of 6 years ago, and the face of someone you now see every day. It lets relevance reshape accessibility. Of course, relevance is not always judged perfectly. Some long useless advertising slogans remain alive long after practical information has left the premises, but in general the principle holds. Forgetting clears space, reduces clutter, and allows current patterns to dominate. This becomes especially important when we think about generalization. The brain often benefits more from extracting a pattern than from preserving every specific instance. You may not remember every single time you saw a dog as a child, but you learn what a dog is. You may not retain each individual breakfast in vivid detail, but you build knowledge of routine, preference, nutrition, and expectation. Forgetting the exact details of repeated similar events can be part of how the brain forms stable concepts. It lets the general survive while many particulars fade. In that sense, forgetting supports learning by reducing unnecessary duplication. This is also why memory across time often becomes less episodic and more semantic. At first, you may remember learning a fact in a specific place on a specific afternoon. Later, you simply know the fact. The original event fades while the knowledge remains. The brain has extracted the useful content and let some of the context go. This is not loss in the tragic sense. it is transformation. Experience becomes understanding, and some of the original scaffolding is no longer needed. Of course, not all forgetting is benign. There are kinds of forgetting that feel more like distortion, suppression, or defense. Sometimes people avoid thinking about painful events, and over time retrieval becomes more difficult in certain ways. Motivated forgetting is a complicated subject, and the brain does not simply press a neat delete button on difficult experience. Painful material may persist strongly, intrude unexpectedly, or fragment rather than vanish. Still, human beings do seem capable of steering attention away from some memories, rehearsing others less, and shaping what becomes easier or harder to access. The mind does not only forget passively. At times, it also participates in forgetting through what it avoids revisiting. There is a gentler version of this in daily life too. Memories that do not fit our current identity or priorities may become less prominent over time. We do not always lose them entirely, but they stop being central. A person who no longer plays an instrument may find those years harder to recall in detail. Someone who has left a certain social world behind may remember it more in outline than in texture. Memory tends to support the life being lived now. Past selves that are no longer active receive fewer reminders, fewer rehearsals, and often fewer routes back. Age changes forgetting as well. Older adults often report more trouble with retrieval, especially for names and recent details, yet many retain broad knowledge and old memories impressively well. Part of this may involve changes in attention, processing speed, hippocampal efficiency, sleep quality, and the general ability to form or retrieve highly specific recent episodes. But aging is not simply one long fall into blankness. It is more selective than that. Some kinds of forgetting increase, yes, especially for new episodic details, while other forms of memory remain strong or even deepen through experience. A lifetime of knowledge can still sit beneath the occasional failure to remember where the reading glasses currently are, which is usually, of course, on one's head. It is also important to remember that confidence and forgetting are not opposites. People can feel certain about memories that are incomplete or wrong, while genuinely stored memories can be temporarily inaccessible and feel absent. Forgetting is messy because memory itself is reconstructive. Sometimes the brain loses access to true details. Sometimes it replaces missing pieces with likely ones. Sometimes it preserves the gist and lets the specifics blur. The system is built to be workable, not flawless. That is one reason forgetting and distortion so often live close together. In fact, forgetting may help make distortion possible. When exact details fade, the brain often fills gaps using expectation, habit, meaning, or later information. You do not remember the precise wording, so you remember what was probably said. You do not recall exactly where the object was, so you remember where it usually is. Most of the time this works well enough. It keeps life moving, but it also means the space left by forgetting is not always empty. Sometimes it gets quietly furnished. That is why forgetting is not simply the disappearance of memory. It is often part of a larger process of simplification and reconstruction. The mind lets go of what seems minor, keeps what seems useful, and then rebuilds the past from what remains. This is efficient, but it also makes memory a little less like an archive and a little more like an editor working with incomplete notes. A very intelligent editor, certainly, but still one under time pressure with a tendency to assume it knows what the missing sentence probably was. There is something almost compassionate in the brain's willingness to let so much go. Without forgetting, grief might never soften, embarrassment would remain at full volume forever, and the ordinary overload of life would become impossible to manage. Yet the same forgetting that protects us from endless accumulation also frustrates us, because it does not always release only what we are happy to lose. It lets go of names we wanted to keep, details we promised ourselves we would remember, practical facts we absolutely needed at 3 p.m. and nowhere else. The system is useful, but it is not tailored to our moment-to-moment preferences. Still, When you step back from the annoyance of losing a word or misplacing a detail, forgetting begins to look less like a flaw and more like maintenance. Decay weakens what is unused. Interference reshuffles what is similar. Retrieval depends on cues that are not always present. Stress and fatigue disrupt the work. And beneath all that, the brain is quietly trying to keep the system from drowning in its own history. It is clearing space, preserving flexibility, and favouring what seems current, repeated, or meaningful. The trouble, of course, is that a memory system willing to simplify, guess, fill gaps, and rebuild from partial traces is not only a system that forgets, it is also a system that can bend. And once we understand that forgetting does not always leave clean, empty spaces, but sometimes creates openings for the mind to reconstruct the past in persuasive but imperfect ways, we begin to move into stranger territory, where memory is not just absent or present, but occasionally very confident and very wrong at the same time. There is something deeply comforting about the idea that memory is a faithful witness. We like to imagine that the mind keeps a reasonably tidy account of what happened, ready to hand over the facts when asked. Perhaps not perfect in every detail, but basically honest. If someone asks where you were, what was said, what you saw, or how an event unfolded, it feels natural to assume that the answer is somewhere inside you waiting to be retrieved. Open the right drawer, and there it is. But memory is not that sort of witness. It is more like a storyteller who usually means well, often gets the main point right, and is forever tidying the edges, borrowing details from elsewhere, and confidently smoothing over gaps with material that feels plausible enough at the time. And that is how we arrive at one of the strangest features of human memory. It can be vivid, sincere, emotionally convincing, and wrong all at once. This is not because the brain is defective in some dramatic way. It is because the brain is doing something more flexible than recording. Memory is reconstructive. Each time you remember, you're not simply taking a perfect original off a shelf and holding it up to the light. You're rebuilding the event from stored pieces. You draw on fragments of perception, emotion, later knowledge, expectation, prior retellings, and the general meaning of what happened. Usually this works well enough. It gives you a usable version of the past, but because it is reconstruction rather than replay, it is vulnerable to distortion. The gaps get filled, the rough parts get smoothed, the uncertain bits borrow support from whatever seems to fit. Over time, that rebuilt version can start to feel just as real as the original experience, sometimes more so. One of the easiest ways to see this is in ordinary conversation. Two people attend the same gathering. Later, one insists the joke came before dinner. The other is absolutely certain it came after. One remembers a blue shirt. The other would stake a small fortune on green. Neither person is necessarily lying. Both may be drawing honestly from memories that have been reconstructed slightly differently. They noticed different details, encoded different elements, attached different meanings, and later retold the event in slightly different ways. By the time the memory is recalled again, those differences have settled in. The mind is not only remembering the event, it is also remembering previous versions of the story. This is one of the great memory traps. Repetition does not always make memory more accurate. Sometimes it simply makes a particular version more familiar. And familiarity, unfortunately, feels a great deal like truth. That matters because the brain is constantly trying to make sense of incomplete information. If a memory is missing details, the mind does not always leave those places blank with admirable scholarly restraint. It often fills them using expectation. If you remember being in a restaurant, your brain may quietly supply the likely layout, the usual sequence of events, or the sort of things people tend to say in that setting. If you remember a classroom, it may insert the standard features of classrooms. Most of the time, this is efficient and harmless. It helps create coherent memory, but it also means that memory can drift toward what probably happened rather than what definitely happened. Psychologists have studied this for decades, and one classic finding is that people are often vulnerable to suggestion after an event. If someone asks, "Did you see the broken headlight?" that question can subtly imply there was one. If the memory was uncertain to begin with, the suggestion may become incorporated. Later, the person may sincerely remember the headlight, not because they saw it clearly, but because the wording of the question helped shape the reconstruction. It is a little unsettling to realize how easily memory can be nudged by later information, but it makes sense once you accept that remembering is an act of assembly. A new piece introduced during assembly can become part of the structure. This is why eyewitness testimony, though often compelling, has to be handled carefully. People can be deeply confident in the inaccurate memories, especially when emotion is involved. Confidence is not a reliable measure of correctness. In fact, some of the most mistaken memories can be delivered with remarkable conviction. The person is not inventing a lie on purpose. They're reporting what the reconstructed memory now feels like from the inside, and from the inside it may feel perfectly solid. Emotion complicates this further. We have already seen that emotional events are often remembered more strongly, but stronger feeling does not guarantee cleaner detail. It may preserve the emotional centre while the surrounding facts blur or shift. A frightening encounter may leave someone certain of the fear, the danger, the bodily sensation, the urgency of escape, yet less accurate about timing, wording, or small visual details. The emotional truth remains vivid, and because it remains vivid, the entire memory may feel unquestionable. But emotion often strengthens significance more than precision. There is also the influence of schemas, which are the mental frameworks the brain uses to organize knowledge. A schema is your built-in understanding of how certain kinds of situations usually work. You have a restaurant schema, an airport schema, a birthday party schema, and unfortunately probably also a standing in line for something boring schema. These frameworks help you navigate life efficiently. You do not need to learn from scratch what is likely to happen when you enter a familiar kind of situation. But schemas also shape memory. If part of an event is unclear, the brain may fill in details that fit the schema. Later you may remember paying the bill after dinner even if someone else paid, simply because paying the bill is the usual thing that happens in restaurants. The inserted detail feels natural, and natural details rarely arrive with a warning label. This is one reason false memories do not always come from dramatic misinformation or intense pressure. Sometimes they arise quietly from the brain's normal effort to create coherence. It prefers a smooth account over a hole in the story. A gap feels unstable. A likely detail feels satisfying, so the likely detail stays. One fascinating example of this comes from experiments in which people are shown lists of related words such as bed, rest, tired, dream, night, pillow, and blanket. Later, many confidently recall having seen the word sleep, even when it was never actually presented. The false memory appears because sleep is strongly associated with the rest of the list. The brain extracts the theme so efficiently that the theme itself can be remembered as if it had been explicitly present. This is not a bizarre malfunction. It is a side effect of one of memory's greatest strengths, its ability to detect patterns and meaning. The same system that helps you understand gist and category can also make you remember a fitting but absent detail. Children and adults alike can be vulnerable to these effects, though in somewhat different ways. Children may be more suggestible in certain contexts because their memory systems and social expectations are still developing. Adults, meanwhile, often have stronger schemas, richer prior knowledge, and greater confidence, all of which can provide their own special routes into distortion. Age does not grant immunity from memory traps. It merely changes the style of the trap. Social influence is particularly powerful. If a group discusses an event, individual memories often begin to shift. People adopt each other's wording, emphasize the same moments, or absorb details mentioned by others. Over time, what was once uncertain becomes shared memory. This can be lovely in families retelling old stories, but it can also blur the line between what one personally experienced and what was later learned from conversation. Many people have memories from childhood that feel first-hand, but are actually partly built from photographs, family stories, and repeated retellings. You may remember the birthday cake, the toy, the weather, and the expression on your face, but some of those details may have been borrowed over the years from hearing the story so often. The memory became a collaboration. Photographs themselves can be surprisingly influential. They seem objective, but they do not simply preserve memory, they also shape it. Repeatedly viewing a photograph can strengthen certain aspects of an event while weakening others. The image becomes the anchor, and memory starts clustering around it. Details outside the frame may fade. In some cases, people even develop confidence in aspects of an event, largely because a photograph gave the memory a structure to build around. The picture may be real, but the memory that forms around it is still a reconstruction. There is another trap hiding in how often we confuse familiarity with recollection. Sometimes something feels known, and the brain quietly mistakes that feeling for having remembered the event itself. A face looks familiar, so you assume you met the person at work, when in fact you only saw them regularly at a cafe months ago. A sentence sounds right, so you assume it was definitely said. A story feels ancient and well known, so you assume you must have been there when it happened. Familiarity is useful, but it is less detailed than true recollection. It tells you that something has been encountered before without necessarily telling you where, when, or how. When the brain confuses the warmth of familiarity for the fuller structure of actual recall, errors creep in very easily. This is closely related to source monitoring, which is the brain's ability to track where a memory came from. Did you see it yourself? Hear about it from someone else? Dream it? Imagine it? Read it? Infer it? Or mix it from several sources at once? Source monitoring is incredibly important and often less reliable than we would like. People may remember the content of a fact or image while losing track of its origin. A person may say, "I remember that happening," when what they really remember is hearing the story many times. Or they may think they came up with an idea independently when in fact they encountered it somewhere before and later forgot the source. That last phenomenon is called cryptomnesia, which sounds like a mysterious ancient curse, but is really just unintentional plagiarism by a brain that has misplaced the label. Imagination can also blur boundaries. The more vividly you imagine an event, the more familiar it can become. If you repeatedly picture yourself doing something, finding an object, saying a phrase, visiting a place, the imagined scene may start to feel memory-like. The brain uses overlapping systems for remembering and imagining, which is wonderfully useful for planning and creativity, but it also means the two can contaminate one another. A vividly imagined future event can feel strangely like a memory of something that already happened. A suggested childhood incident, if imagined often enough and discussed in the right way, can begin to feel disturbingly real. The mind is not simply replaying the past. It is using many of the same tools to construct the possible, the probable, and the remembered. That overlap is part of why memory is so flexible, but flexibility always carries the risk of drift. The very systems that let you plan tomorrow by recombining yesterday also make yesterday somewhat vulnerable to reconstruction. A mind that could only replay perfectly would be less creative, less adaptable, and perhaps less able to understand patterns across time. Human memory pays for usefulness with a certain amount of inaccuracy. There are also distortions that emerge from mood and belief. People often remember the past in ways that support their current identity, worldview, or emotional state. This is not always conscious. Someone who sees themselves as resilient may remember difficulties through a lens of overcoming. Someone in a depressive state may retrieve the past as evidence of repeated failure or loss. Couples may remember the early days of a relationship as warmer or colder, depending on how they currently feel about it. Political beliefs, group loyalties, personal values, and emotional needs can all subtly reshape what feels memorable and what meaning is assigned to it. Memory does not live outside interpretation, it is threaded through it. This can be seen in something as simple as nostalgia. Nostalgia often smooths the past. It heightens warmth, softens irritation, and organizes experience into a gentler emotional story. That is not necessarily bad. It can comfort, strengthen identity, and connect people to meaning. But it does mean the remembered past is not always the past as it was. The same goes for regret, which can sharpen different edges, emphasizing mistakes and missed chances while flattening the complexity of what was actually possible at the time. Memory is rarely neutral, it is emotionally edited. There are even cases where repetition can produce a false sense that something is true simply because it has been heard many times. This is sometimes called the illusory truth effect. Repeated statements feel more fluent to process, and fluent things feel more believable. In memory terms, repetition creates familiarity, and familiarity often masquerades as credibility. The brain is fond of what goes down smoothly. Unfortunately, truth and smoothness are not the same thing. A repeated falsehood can settle into memory not because the evidence supports it, but because the mind has grown used to it. This is one reason misinformation can be so sticky. Once embedded, it becomes part of the material from which later memories are constructed. That stickiness helps explain why correcting false memories is not always simple. Telling someone the accurate version does not automatically dissolve the inaccurate one. The original mistaken memory may already be integrated, repeated, and emotionally supported. In some cases, the correction has to compete with the false memory, instead of replacing it neatly. This is not because people are stubborn by nature, though of course they often are. It is because memory is not a clean document that can be edited without residue. It is a living network. Once a mistaken detail settles into that network, later truth must work to find its place. There is something humbling in all of this. We like to think of ourselves as knowing what we remember. Yet much of the time, we remember the meaning of events more securely than the details. We carry the emotional shape, the broad lesson, the general story, and then trust the details because they feel close enough. And most of the time, that is good enough to live by. You do not need a courtroom-level reconstruction of every breakfast conversation you have ever had. Life would become unbearable if you demanded that standard from daily memory. The system is built for function, not flawless historical archiving. Still, understanding these traps matters. It makes us gentler with ourselves when memory slips or shifts. It makes us a little more cautious with certainty, especially when the memory in question arrived through stress, suggestion, repetition, or social retelling. It also explains why people can disagree honestly about the past. They may not be defending lies. They may be defending reconstructions built with different materials. At the same time, false memories are not only a warning about error, they're also a clue about what memory is really for. A system designed to extract patterns, preserve gist, support identity, guide prediction, and reconstruct meaning will always be somewhat vulnerable to distortion. That vulnerability is the shadow side of flexibility. The brain trades perfect recording for usefulness. It keeps what helps most often, fills what is missing, and rebuilds the rest as needed. Remarkably, it works as well as it does. And yet this balance between remembering and reconstructing does not stay constant throughout life. The kinds of errors we make, the kinds of memories we hold, and the ease with which we retrieve them all shift with age. A child remembers differently from an adult. An older mind does not fail in the same pattern as a young one. Across the years, memory changes shape, not simply in strength or weakness, but in style, emphasis, and the kinds of traces the brain is best equipped to keep. Memory does not stay the same throughout life, and that is not because the brain spends the years slowly becoming less interested in cooperating. It changes because the brain itself changes, its structures develop, its priorities shift, its networks strengthen, its habits settle, and the meaning of experience grows more layered over time. A child does not remember the way an adult remembers. An older person does not forget in quite the same way a tired student forgets. The memory of a teenager is not simply a smaller or weaker version of the memory of a middle-aged person. It is organised differently, shaped by different needs, different biology, and different kinds of attention. Across a lifetime, memory is not one steady ability that either rises or falls. It is a moving system, changing shape as the person changes with it. This begins very early, long before anyone can describe it. Babies learn constantly. They learn the sound of familiar voices, the smell of caregivers, the rhythm of routines, the feel of safety, the timing of feeding, the distinction between calm and alarm. They do not arrive in the world with an empty mind waiting politely for instructions. They're already building patterns from experience. A baby can remember in important ways. Preferences form, recognition forms, associations form, expectations form. What a baby usually cannot do, at least not in the way adults later understand it, is build the kind of rich autobiographical memory that says, "This happened to me in that place, at that time." The systems for that kind of memory are still developing. This is one reason most adults remember almost nothing from the first years of life. It is not because nothing was learned then, quite the opposite. The early brain is absorbing an enormous amount. But the type of memory being built is not yet fully the kind that later produces a stable narrated personal past. The hippocampus is still developing, language is still emerging, the sense of self as a continuing story is still very young. Experiences matter deeply, but they are not being stored in the same organised autobiographical form that an adult later uses to recall childhood birthdays, school corridors, or the exact unfairness of a sibling receiving the larger biscuit. This phenomenon is often called childhood amnesia, though it is less a dramatic amnesia than a mismatch between early learning and later recall. Adults usually cannot consciously revisit the earliest years in detail, yet those years still shape them. Emotional patterns, attachments, sensory preferences, expectations of comfort and distress. All of these can leave lasting traces. A person may not remember being soothed as an infant, but the nervous system can still carry the consequences of being soothed reliably or not. Memory, in that sense, begins before storytelling does. The body and brain learn the world before the self can narrate it. As children grow, memory becomes more visible in the everyday sense. Language helps enormously. Once experiences can be named, described, and shared, they become easier to organise and revisit. A child who can say what happened has more tools for holding on to it. Conversation plays a powerful role here. Adults who talk with children about past events, who help them describe what happened, how it felt, what came first, what came next, are not simply making polite family talk. They are helping build autobiographical memory itself. They are teaching the child how to structure experience into story. This is one reason family style matters. In some families, the past is discussed richly and often. People revisit outings, mishaps, holidays, little triumphs, lost shoes, strange weather, grandparent remarks, and the day the cake collapsed in a way now considered charming. In those environments, children get practice linking time, self, emotion, and narrative. In other families, the past may be discussed less or less elaborately. An autobiographical recall can develop a little differently. Memory is biological, certainly, but it is also social. We learn not only to remember, but to remember in certain ways. During childhood, memory expands quickly, but it is not yet especially disciplined. Children can be extraordinary at absorbing detail when interested, and spectacularly uninterested in preserving information adults consider important. A child may forget an instruction delivered 30 seconds ago, and yet remember with total confidence that a beetle under a park bench had one bent leg and looked angry. This is not random. Attention still rules the gate. What matters to the child's mind gets in more easily than what matters to the adult who's trying to get everyone into the car before dark. Working memory also develops through childhood. The ability to hold and manipulate information grows, which helps with language, planning, problem solving, and learning in school. A young child has a more limited working memory span and less efficient control of attention than an older child or adult. This means memory challenges in early childhood are often not only about storage, but about how much can be actively managed at once. Following multi-step instructions, remembering sequences, or holding a rule in mind while doing something else gradually becomes easier as these systems mature. School years bring another major shift. Children begin learning in more structured ways, often asked not only to remember events, but to retain facts, categories, rules, symbols, and abstract relationships. Repetition becomes central. Meaning becomes central too. Though schooling does not always announce this clearly enough, children remember far better when facts connect to stories, examples, and relevance rather than floating alone like isolated bits of administrative debris. A child may forget a definition, but remember the experiment, the demonstration, the funny example, or the classroom moment when the concept finally made sense. Memory is already showing the same preferences it will keep for life. It favours meaning, emotion, structure, and repeated use. Then comes adolescence, which is its own complicated memory climate. The brain is changing rapidly again. Social life becomes more emotionally charged. Identity becomes more central. Novelty is abundant. First freedoms, first serious embarrassments, first intense friendships, first romantic experiences, first confrontations with failure or independence. All of these tend to arrive with strong feeling and high personal meaning. It is no accident that many people remember adolescence and early adulthood with unusual vividness. These years are crowded with firsts, and the brain pays attention to firsts. There's also a phenomenon sometimes called the reminiscence bump, in which older adults often recall a disproportionate number of memories from adolescence and early adulthood compared with some later decades. Researchers think this happens partly because those years are so rich in novelty, identity formation, and major life transitions. Experiences from that period help define the self. They are rehearsed more. They are tied to emotionally charged milestones. The result is that a song from age 17 or a street from age 21 can survive in memory with astonishing brightness, while whole stretches of later routine blur together like a respectable but somewhat forgettable spreadsheet. Adolescence also reveals how mood and social emotion shape memory. Shame can become memorable with painful efficiency. Pride can do the same. A casual sentence from a peer or parent may settle deeply because identity is so active, so exposed, so under revision. This does not stop in adulthood, of course, but adolescence often gives these emotional imprints unusual force. Memory in those years can feel highly personal because nearly everything feels tied to the question of who one is becoming. Early adulthood often extends this intensity. New places, work, university, love, disappointment, responsibility, travel, risk, and self-definition create strong memory conditions. Many people are living through repeated novelty while also building the story they will later tell about the beginning of their adult life. The brain is exceptionally busy linking memory to identity. Decisions feel large because many of them are. First jobs, first homes, first losses born without childhood protections, first attempts at becoming a stable person while still improvising wildly underneath. All of these give memory a lot to work with. Then for many people, life gradually becomes more patterned. This is not necessarily dull. It can be rich, meaningful, and deeply satisfying. But repeated routines do change the texture of memory. Once the first apartment becomes the 5th year in the same home, once the first job becomes the familiar weekly rhythm, once the daily routines of work, parenting, commuting, making dinner, paying bills, and trying to remember whether anyone defrosted anything begin repeating, memory shifts again. The brain becomes efficient. It keeps the structure and lets many specifics fade. This is useful. It would be exhausting to encode every near-identical Tuesday with equal intensity. That efficiency, however, contributes to the common feeling that time speeds up in adulthood. It is not necessarily that the years are objectively moving faster, it is that fewer days stand out as distinct memory landmarks. Novelty creates more mental markers, routine creates fewer. When the brain looks back over a period filled with repeated patterns, there may be less vivid detail to stretch the sense of duration. A year packed with new experiences often feels longer in retrospect than a year of familiar rhythms, even if the calendar politely insists both contained the same number of months. Adulthood also brings expertise, and expertise changes memory in powerful ways. People begin to remember better within the domains they know well. A seasoned doctor notices patterns in symptoms that a non-expert would miss. A musician hears structures others barely register. A parent remembers details related to a child's needs with astonishing speed, while perhaps forgetting their own lunch entirely. Knowledge creates scaffolding. The more a person knows in an area, the easier it often becomes to remember new related information, because it can attach to existing structure. Memory becomes more efficient not only by forgetting routine, but by organizing what matters into richer networks. This is one of adulthood's great strengths. While younger people may have advantages in certain kinds of raw learning speed or flexible working memory, older adults often bring far greater stores of knowledge, pattern recognition, and semantic memory. They know more, not just as a matter of facts, but as a matter of structure. This makes memory less about isolated details and more about systems of understanding. A highly experienced person may not recall every exact event as sharply as a younger one, yet may understand the meaning of events more quickly and more deeply, because they have seen related patterns before. Middle adulthood often combines strong semantic memory, practice skills, social and emotional experience, and deeply routinized life. It can also bring strain. Work pressure, caregiving, poor sleep, stress, divided attention, and mental overload all affect memory. Many people in this phase worry that they are getting worse mentally when what they are often experiencing is chronic interference. Too many tasks, too little sleep, too many partial attentional commitments, too much context switching, and too many things held in working memory at once can make anyone feel forgetful. The brain's capacity has not vanished. It is simply being asked to juggle a rather rude number of flaming objects. That is why everyday forgetting in adulthood is so often about attention rather than decline. You forgot the email because you were answering a message while thinking about dinner and listening for the washing machine. You misplaced the keys because you set them down while already planning tomorrow. You failed to remember the name because you were tired, and the introduction happened in a noisy room between other demands. These lapses can feel worrying, but many of them reflect the conditions under which modern adults use memory, not a dramatic collapse of memory itself. Later adulthood brings further changes, and this is where memory becomes especially misunderstood. People often speak as though aging simply means loss, but the truth is more specific and more interesting. Certain forms of memory do tend to become less efficient with age, especially episodic memory for recent events and details, speed of retrieval, and sometimes working memory capacity. Names may take longer to come. A story may be remembered well while the date attached to it goes wandering. A person may know perfectly well who someone is, and yet need a frustrating extra moment for the name to surface, usually after they have already moved on and rendered the whole effort socially pointless. Yet other forms of memory remain strong, or can even appear stronger because of the sheer accumulation of knowledge. Vocabulary often holds up very well. General world knowledge, understanding of language, deeply practiced skills, and broad semantic memory can remain impressive. An older adult may struggle to recall where the glasses were last placed, yet offer rich insight, detailed historical knowledge, layered stories, and nuanced understanding of people and situations. Memory in aging is not a flat decline. It is a redistribution of strengths and weaknesses. Part of the difficulty with recent episodic memory and aging may relate to changes in the hippocampus and related networks, as well as changes in attention, sleep quality, and processing speed. Forming a new detailed memory can require more effort. Retrieving it may require stronger cues. Interference can become more noticeable. Similar experiences may blur more easily, but this does not erase a lifetime of learning. In many cases, the older brain is remarkably wise, even while occasionally slow to fetch the label from the correct drawer. It is also worth noting that older adults often remember emotionally meaningful material relatively well. Positivity biases sometimes emerge too, with some older people attending more to emotionally satisfying or meaningful information than to trivial negative detail. This is not universal, but it suggests that aging memory may become more selective in a direction shaped by values and emotional priorities. The brain continues to edit according to what matters. Of course, there is a difference between healthy aging and disease. Normal aging may involve slower retrieval and more difficulty with recent episodic detail, but conditions such as Alzheimer's disease involve deeper disruptions, especially in forming and keeping new memories. In those cases, the changes are not merely part of the ordinary lifespan pattern. They reflect damage to core memory systems, often beginning around the hippocampus and related structures. This distinction matters because ordinary age-related lapses can be frightening enough without every lost word being interpreted as catastrophe. Memory changes with age, yes, but it does not always do so pathologically. Across the whole lifespan, one theme stays constant. Memory reflects what the brain is built to prioritize at a given stage. In infancy, attachment, sensory patterning, and basic learning dominate. In childhood, language, routine, and growing autobiographical structure expand. In adolescence and early adulthood, novelty and identity leave deep marks. In mature adulthood, expertise, meaning, and pattern recognition grow while routine compresses time. In later life, semantic depth and emotional meaning often remain strong even as recent detail may require more support. The memory system is always adapting to the demands of being the age you are. That is why it can be misleading to compare memory across ages as though there were one ideal standard. The memory of a child is not worse than that of an adult in every sense. It is often more open to novelty and less organized by long habit. The memory of an older person is not simply poorer than that of a younger one. It may be slower in some ways and far richer in others. Each stage gains and loses different things. The brain is not climbing one straight hill and then rolling sadly downward. It is changing roles as life changes. There is something comforting in that, because it means memory is not separate from life. It is not a machine attached to you from the outside. It grows with you. It records what matters to the age you are, shaped by the body you have, the routines you repeat, the emotions you carry, the stories you tell, and the meanings you build. Childhood remembers one way because childhood is one kind of world. Older age remembers another way because older age is another kind of world. The system bends with the person, and through all these years, some of the strongest memories are not always the grand public ones. Many are the quietly repeated ones. The way a parent tied your shoes, the route to school, the smell of a house, the sentence a teacher said, the motion of practice turning into skill. These are not always dramatic episodes. Sometimes they are patterns laid down so steadily that they stop feeling like memories at all and begin to feel like part of the self. That is where the story turns next, toward the things the brain remembers not as events you deliberately revisit, but as actions, habits, and learned abilities that settle so deeply you can carry them without thinking. There is a special kind of memory that rarely announces itself. It does not arrive with the vividness of a birthday, the ache of a heartbreak, or the clear image of a room you once stood in. It does not usually ask you to sit down and deliberately revisit it. In fact, the more fully it develops, the less you tend to notice it at all. It lives in the things your body can do, the routines your days fall into, the skills your hands perform before language catches up, the patterns your mind has learned so deeply that they stop feeling like memories and start feeling like part of how you move through the world. This is the domain of habits, skills, and deep learning. The strange and rather remarkable class of memory that often works best when you're not trying to remember anything at all. If someone asks what you remember from yesterday, you might mention a conversation, a meal, a bit of news, or the fact that you absolutely meant to answer that message and then somehow entered a tunnel of unrelated tasks from which you emerged 2 hours later, holding a spoon. But if someone asks whether you remember how to tie your shoes, type your password, ride a bicycle, make tea, pronounce certain words, or find your way around your home in the dark, the question feels almost odd. Of course you do. Yet in a very real sense, you do remember these things. The memory is simply stored and expressed differently. This is one of the most important distinctions in the whole story of memory. Not all memory is conscious recall. Some memory is explicit, meaning you can bring it to mind deliberately and describe it. Other memory is implicit, meaning it affects what you do, feel, notice, or predict, without necessarily becoming something you can explain in words. You may not be able to describe every movement involved in balancing on a bicycle, but your body can perform them. You may not be able to state all the rules of grammar in your native language, yet you can instantly hear when a sentence sounds wrong. You may not remember learning how to use a keyboard, but your fingers move across it with a fluency that would have looked impossible to your younger self. These are memories without narration, learning without constant conscious consultation. One of the best examples is procedural memory, the kind involved in skills and actions. Procedural memory helps you perform tasks that become smoother with practice. Riding a bicycle is the famous cliché here, but clichés become clichés for a reason. Once learned well, some skills are astonishingly resilient. A person may go years without cycling and still find the balance returning. They may be rusty, cautious, and a little too aware of the possibility of falling over in a way that is both physically minor and emotionally offensive, but the underlying skill often remains. That is because procedural learning changes the brain differently from the way episodic remembering does. The skill becomes embedded in systems built for repeated action, timing, coordination, and habit. Several brain regions are important here, especially the basal ganglia and the cerebellum. The basal ganglia help with habit formation, action selection, and the automation of repeated behaviors. The cerebellum is crucial for coordination, timing, and the fine-tuning of movement. Together with motor areas of the cortex and other networks, they help transform clumsy effort into smooth performance. When you first learn a new skill, you often rely heavily on attention and working memory. You think through the steps, you hesitate, you overcorrect. You may feel as though your whole mind is leaning awkwardly into the act, trying to supervise every part at once. Over time, with repetition, the skill becomes more automatic. The brain shifts from explicit effort toward efficient patterned execution. This change is one of the most satisfying things learning can do. At first, you have to think about every movement. A new driver grips the wheel as if negotiating peace with the car. A beginner pianist stares at the keys and seems to require several separate brains to locate the right finger. A person learning to cook may read the recipe with the tense reverence usually reserved for ancient legal documents. But with practice, the body begins to remember. The hands know where to go. The timing becomes intuitive. The pieces group into larger units. What once required deliberate step-by-step attention becomes chunked into manageable patterns. Chunking is a useful idea here. The brain gets better at grouping smaller actions or bits of information into larger, meaningful units. An expert typist is not thinking about every letter as an isolated movement. A skilled reader is not decoding every word from scratch. A practiced musician does not treat every note as a separate emergency. Experience allows the brain to compress patterns into workable wholes. This makes performance faster, smoother, and less demanding of conscious effort. It also makes the skill feel natural, which is one reason people sometimes forget how much practice produced it. What is automatic often gets mistaken for what is easy, when in fact it is simply what has been deeply learned. This kind of deep learning extends beyond movement. Cognitive habits work similarly. Mental arithmetic, reading, driving familiar routes, recognizing emotional tones in other people, noticing patterns in professional work, all of these can become more automatic with experience. A doctor may spot a concerning pattern in symptoms almost instantly, not because of magic, but because years of repeated exposure have built a rich network of pattern recognition. A chess player sees structures on the board that a novice cannot yet perceive. An editor notices rhythm, error, and awkward phrasing without consciously scanning for each one. These abilities feel like intuition, and in a sense they are, but intuition is often memory that has become fast. This is one of the most remarkable outcomes of repeated learning. The brain does not only store what happened, it extracts regularities, it begins to predict, it prepares. Over time, it becomes able to respond before full conscious analysis is finished. That can look mysterious from the outside, but it is often the product of countless encounters quietly training the system. Deep learning is, among other things, the art of turning repeated experience into rapid judgment. Habits are related, though they deserve their own attention because they reveal something both powerful and a little unnerving about memory. A habit is a learned pattern of behavior that becomes triggered by context and repeated enough to run with relatively little conscious oversight. You wake up and reach for the kettle. You lock the door in the same sequence. You check your phone at certain pauses. You brush your teeth while thinking about something entirely unrelated. Much of daily life is scaffolded by habit, which is one of the reasons life remains manageable. If every routine action required full deliberate planning, people would be exhausted by breakfast. Habits save effort by reducing the need for constant decision-making. The brain loves efficiency, and habits are efficient. A repeated behavior linked to a stable cue can become easy to perform because the pathway has been used so often. This is practical and helpful when the habit is making lunch, going for a walk, stretching after work, or putting your keys in the same sensible place every evening. It is less delightful when the habit is checking your phone every 4 minutes, reaching for sugar automatically under stress, or saying you too when a waiter tells you to enjoy your meal. The habit system does not care much about dignity. It cares about repetition and context. That is why habits can be so hard to change. Once a behavior has been repeated under similar circumstances many times, the cue and the action become linked. The brain begins to anticipate the behavior. It becomes the path of least resistance. Breaking that pattern requires more than simply deciding not to do it. It often requires changing the cue, the routine, the reward, or the environment around it. In other words, it requires building a new memory pattern strong enough to compete with the old one. Memory is not only what you can recall, it is also what your nervous system expects to do next. This expectation is especially clear in conditioned responses. If a person repeatedly experiences a certain cue alongside a certain outcome, the cue can begin to produce anticipatory reactions on its own. A smell associated with illness may produce discomfort years later. A song tied to a former relationship may alter mood before the listener has consciously thought why. The body remembers patterns of association. In some cases this is highly adaptive. In others it becomes inconvenient, even painful. But it all belongs to the larger category of deep learning. The brain is always absorbing relations between events and preparing future responses based on past repetition. This is why implicit memory can feel so physical. Sometimes the body knows, before the person can explain what it knows. You walk into a place and feel uneasy. A certain tone of voice makes you tense. A familiar kitchen allows your hands to move confidently without much thought. None of this necessarily requires a deliberate conscious memory to appear. The system has learned patterns and stored them in ways that guide action, posture, expectation, and feeling. experience leaves traces not only in narrative memory, but in reflexes of attention and behaviour. Language offers another excellent example. Most people cannot explain the full grammar of their native language, yet they use it fluently. Children do not learn language by memorising formal rules first, and then applying them like tiny civil servants. They absorb patterns through repeated exposure, interaction, correction, and use. Over time, those patterns become so deeply embedded that the speaker simply knows when something sounds wrong. That knowledge is real, but much of it is implicit. It exists as a deeply learned system of expectation, rather than as a list of consciously retrievable instructions. The same is true for social life. Much of what people know about interaction is not stored as explicit doctrine. It is learned through repeated experiences of tone, timing, facial expression, approval, disapproval, closeness, distance, trust, and threat. People remember how conversations feel. They learn when to speak, when to hold back, how to detect irritation, how to sense comfort, how to navigate group norms, how to read when a joke has landed and when it has died quietly in the room like a bird flying into clean glass. These are social memories, and many of them become fast, tacit, and embodied. This can be a source of strength, but it can also preserve unhelpful patterns. If a person grows up repeatedly learning that speaking up leads to embarrassment, silence may become habitual. If asking for help was often met with warmth, help-seeking may become easier. If conflict consistently ended badly, the body may learn to brace before the mind has fully understood what is happening. Deep learning does not sort carefully between what is wise and what is merely familiar. It strengthens what is repeated. That is both its power and its danger. One of the most interesting aspects of skill memory is that it can survive forms of memory loss that damage conscious recall. As mentioned earlier in the story of Henry Molaison, a person with severe difficulty forming new episodic memories could still improve on certain motor tasks over time, despite not remembering having practiced them. This is one of the clearest pieces of evidence that skills and habits rely on systems somewhat distinct from conscious event memory. The body and brain can learn even when the person cannot later narrate the learning episode. That is a humbling reminder that memory is broader than awareness. The mind is being shaped by repetition even when it cannot always describe the process in words. Sleep helps here too. Practice during the day is often followed by better performance after sleep, not only for facts but for motor skills and procedural learning. A pianist may rehearse a passage, struggle with it, and then find it more stable the next day. A person learning a sport, a dance, a sequence of movements, or even a tricky set of finger patterns on a keyboard may improve after rest. The brain appears to consolidate not just declarative material during sleep, but procedural patterns as well. Silence and repetition continue to collaborate after conscious effort has ended. There is also the role of myelination and efficiency across repeated use. Myelin is the fatty insulating material around many nerve fibers that help speed signal transmission. Repeated practice and development can support more efficient communication in neural pathways. The skill becomes not just familiar, but more physically streamlined in how the brain carries it out. This is part of why practiced actions can feel so smooth, and why early clumsy effort can later become elegant. The nervous system is being tuned. Experts often describe this shift in interesting ways. They no longer think about every detail consciously. In fact, thinking too much can interfere. Athletes sometimes perform worse when forced to overanalyze movements that have become automatic. Musicians can stumble when attention lands too heavily on actions that normally run through practice flow. This phenomenon is sometimes called choking under pressure, though that phrase makes it sound more theatrical than it is. What is really happening is that conscious control intrudes awkwardly into patterns that were functioning best as well-trained automatic sequences. It is rather like a manager barging onto the factory floor to personally oversee a process the workers already understand perfectly. This reveals something important about deep learning. success often involves a transfer from effortful control to trusted automaticity. At first, consciousness teaches. Later, it gets out of the way. That does not mean attention becomes irrelevant forever. Refinement still requires focus. Advanced skills still need correction, practice, and deliberate shaping. But once the underlying pattern is well learned, performance often improves when consciousness allows the trained system room to operate. It is also worth noticing how much identity can become entangled with these deep memories. A person who has spent years writing, singing, building, caring, teaching, fixing, drawing, running, dancing, or speaking another language does not simply possess those skills as separate tools. They often feel woven into the self. To stop practicing them can feel like losing touch with part of one's own structure. That is because repeated action is not only changing what the brain can do, it is also shaping how the person understands who they are. I am a runner. I am a pianist. I am someone who cooks. I am not the sort of person who gives up easily. These identities are built through repeated enactment. Habits and skills become biographies in miniature. At the same time, deep learning explains why change is possible even later than people often assume. Because the brain remains plastic, repeated new patterns can still become established. Habits can shift. Skills can be learned. New routines can become natural. Old pathways may remain strong, but they need not rule forever. Repetition, again, is the key. The nervous system keeps learning from what it does repeatedly. That is hopeful, though it is also unforgiving. It means that what you practice, intentionally or not, is shaping what becomes easy. This includes thought patterns, worry, self-criticism, attentional habits, emotional reflexes and interpretive styles can all become practiced forms of deep learning. A person who repeatedly responds to uncertainty with panic is reinforcing one pattern. A person who repeatedly interrupts that panic with grounding, breathing, reframing, or action is reinforcing another. The same broad principles apply. Repetition plus context plus emotional relevance produce pathways. Over time, those pathways become more available. Deep learning is not limited to piano scales and tennis serves. It reaches into the very style of a person's inner life. And yet, for all their strength, habits and skills can be strangely invisible, because they do not present themselves as memories in the dramatic sense. People often underestimate them. They think of memory as what they can recount and forget the enormous territory of what they can do, anticipate, notice, and repeat, because the brain learned it well enough to stop asking permission. Much of what makes a person recognizable to themselves is held there. The way they stir soup, the route they take home, the posture they adopt when thinking, the accent that remains in certain words, the reflex to comfort a child, the tendency to reach for music while cleaning, the ability to laugh at exactly the wrong moment and somehow survive socially. These are memories too. They're just quieter. They live below the level of deliberate recall, steady and often taken for granted, until something interrupts them. An injury makes walking suddenly effortful and reveals how much had once been automatic. A long break from a skill shows what remains and what needs refreshing. Returning to an old instrument, an old language, an old house, or an old route often produces the uncanny experience of deep memory stirring before conscious thought has fully arrived. The hands know, the body leans, the system remembers. All of this tells us something profound about memory's purpose. Memory is not only there to let you revisit the past, it is there to let the past shape the present efficiently. It helps you act without starting from zero each time. It teaches the body what to expect, the mind what to notice, the hands what to do, the voice how to move, the self how to continue. It is the accumulated training of a life becoming usable. And that brings us quietly toward the final question underneath all the others. If memory includes vivid episodes, emotional imprints, forgotten traces, false reconstructions, childhood patterns, aging changes, and the silent learning of habits and skill, then what is the brain really trying to do with all this selection? Why remember these things and not others? Why keep certain fragments, release others, and build a life out of such uneven materials? To answer that, we have to step back from individual kinds of memory and look at the broader design, the mind selective archive, where remembering and forgetting turn out not to be opposites at all, but partners in the same strange and necessary task. By the time we reach this point, memory no longer looks like a simple storage system. It looks more like a living arrangement between keeping and letting go. Some things stay because they were emotional, some because they were repeated, some because they were useful, some because they attached themselves to who you are. Others vanished because attention never fully opened for them, because routine flattened them, because new information crowded them out, or because the brain quietly decided it had more important work to do. And if there is one thing that becomes clearer the longer you look at memory, it is this. Remembering does not happen in spite of forgetting. It happens with forgetting. The two are partners. That can feel counterintuitive because forgetting is usually the part we complain about. No one sits down, fails to remember where they put an important document, and says with serene appreciation, "Ah, yes, what a beautiful demonstration of adaptive cognitive efficiency." Usually they say something less elegant. We notice forgetting when it inconveniences us, embarrasses us, or interrupts a plan. But the brain is not built to satisfy every small preference in the moment. It is built to manage life across time. That means it has to decide what deserves energy, what deserves space, and what deserves a route back into awareness later. If it tried to preserve everything equally, it would stop being useful very quickly. A selective archive is exactly what memory has to be. Not a perfect record, not a neutral camera, not a warehouse where all moments wait in neat boxes, but an active system that extracts what seems valuable from the flow of experience. The brain is constantly asking, though rarely in words, what should remain accessible, what can be compressed, what can be generalized, what can be released, and what must be held tightly because it may matter again. That process is not flawless. It can be frustrating, biased, oddly sentimental, and at times almost comically unhelpful. Yet without it, thought itself would become cluttered beyond use. Imagine, just for a moment, what memory would be like without forgetting. Every face you had ever seen would arrive with equal insistence. Every trivial sentence would compete with the important ones. Every route, every noise, every password, every shopping list, every half-heard conversation in every cafe, every boring Tuesday detail, all of it pressing forward with the same clarity. You would not have a richer mind. You would have a crowded one. Recognition would become slower. Relevance would become harder to judge. The signal would drown in the noise. Forgetting is what prevents the past from flooding the present so completely that nothing current can be done with ease. This means forgetting is not just an unfortunate leak in the system. It is part of the filtering that gives the system shape. It keeps memory from becoming indiscriminate. It allows important patterns to stand out by letting less useful detail soften. You do not need to remember every single door you have opened in order to know how doors work. You do not need to preserve every identical commute in cinematic detail in order to know the way home. You do not need to consciously recall every evening someone cared for you in order to carry the deeper expectation that care can exist. In many cases, the brain gains usefulness precisely by allowing particular details to fade while preserving broader patterns, meanings, and skills. That balance between detail and pattern is one of memory's greatest achievements. On the one hand, memory must preserve enough of specific events to let you learn from them, recognize people, tell your story, and remember where you left the umbrella. On the other hand, it must generalize. It must notice that this face belongs to a friend even if the lighting is different. It must know how to walk into a kitchen and use it even if it is not your own. It must understand what a birthday, a goodbye, a warning sign, or a kind tone usually means across many separate encounters. If memory held only isolated snapshots, life would feel endlessly new and endlessly difficult. If it held only general patterns, personal life would lose its texture. The brain needs both, and forgetting helps it move between them. This becomes especially clear in learning. When you first encounter something new, the brain is often full of details. The exact example, the teacher's voice, the page layout, the awkward first attempt, the mistake that made you laugh, all of that may be attached to early learning. But over time, as repetition and meaning do their work, the specific circumstances may fade while the knowledge remains. You no longer remember the first day you learned a particular word, but you know the word. You no longer remember every childhood attempt at tying your shoes, but you can tie them. You no longer remember every route taken to a familiar place, but the path has become part of you. Forgetting some of the scaffolding allows the structure itself to stand more cleanly. There is a kind of quiet elegance in that. The brain is not trying only to preserve the past, it is trying to make the past usable. It is turning lived experience into guidance. It is asking, in effect, what can be carried forward in a form that helps. Sometimes that means preserving a vivid episode. Sometimes it means extracting the lesson and dropping the details. Sometimes it means holding on to the feeling long after the scene itself has blurred. Sometimes it means converting repeated action into habit until you no longer need to think about it consciously. Remembering is not a single act. It is a series of transformations, and forgetting is woven through those transformations all the way. This is also why memory is so closely tied to identity. What you remember, what you forget, what stays vivid, what softens, what returns easily, what requires a cue, all of these things help create the sense of a self moving through time. Identity is not built from every fact equally. It is built from a selected past. The people you loved, the places that mattered, the humiliations that taught caution, the successes that gave confidence, the routines that shaped daily life, the losses that reorganized the world, the repeated choices that became character. Much of who you feel yourself to be depends on the archive the mind has kept, and the archive it has allowed to fade into background. This does not mean memory gives you a perfectly objective self. Far from it. Identity, like memory, is reconstructed. It is built from selected moments, repeated interpretations, emotional emphasis, and the stories you have told often enough that they now feel like the obvious shape of your life. But that does not make it false. It makes it human. A mind that remembers is also a mind that interprets. It is always arranging the past into forms that help the present make sense. Forgetting is part of that arrangement. Painful events may soften enough to become bearable. Childhood details may blur while their emotional consequences remain. Whole stretches of routine may shrink in recollection, while turning points remain bright. This is not always comfortable. There are people we wish we remembered more sharply, years we wish we could revisit with greater clarity, and facts we absolutely wanted to keep. But the brain's goal is not sentimental completeness. It is navigable continuity. It is trying to preserve enough for life to feel coherent without preserving so much that the mind drowns in the sheer weight of its own record. There are, of course, costs to this. The same selectivity that lets memory stay useful also makes it uneven. It keeps the song lyric and loses the surname. It remembers the embarrassment and misplaces the practical instruction. It gives you the smell of a childhood house with astonishing clarity while withholding the password you changed yesterday. It preserves emotional truth while smudging the order of events. It fills gaps with likely details and then asks to be trusted anyway. This can be maddening. Yet it is the cost of a system built for flexibility instead of exact replay. And flexibility matters. The world changes. People change. Goals change. What was once essential can become irrelevant. What once seemed irrelevant can become newly important. Memory has to remain capable of reweighting experience. It has to allow current life to shape access to the past. That is why the same person can feel differently about the same memory across the years. The event has not changed, but its place in the larger archive has. It may move closer to the front because it now means something new, or it may recede because other experiences have given it a different scale. Forgetting is not always erasure. Sometimes it is simply movement deeper into storage, out of daily reach unless something calls it forward. This is where cues become so powerful. A smell, a street, a melody, a voice, a phrase. These can suddenly pull something back from the selective archive and make it vivid again. A memory you would have sworn was long gone appears with surprising force, bringing not just fact but atmosphere. That tells us something important. Not everything that is forgotten is destroyed. Some things are merely less accessible until the right key appears. The archive is not fully visible at all times. It is dynamic. It opens differently depending on mood, context, need, and chance. That dynamic nature is one reason memory can still surprise us so late in life. An older person may hear a song from youth and find an entire scene opening behind the eyes. A scent can return a decade. A familiar recipe can bring back a kitchen no longer standing. A phrase heard in passing can revive a teacher's voice after years of silence. The brain does not keep everything near the surface, but it does keep more than we sometimes think, tucked into associations waiting patiently for the right kind of invitation. At the same time, the selective archive is still editing. Even as it retrieves, it reshapes. Every act of remembering is also a fresh act of construction. The mind does not simply open the past and observe it from a respectful distance. It engages with it in the present. It brings current knowledge, current emotion, current identity, and current needs into the process. That means memory stays alive, but it also means memory is never completely finished. What you remember now is partly the past and partly the present mind meeting it. This sounds a little unsettling at first, but there is something profoundly practical in it. A rigid memory system would preserve pain at full volume forever, and might never allow new understanding to change the emotional meaning of old events. Human memory, by contrast, allows revision. Not always enough, not always kindly, but enough that growth is possible. A humiliation can become a story. A grief can become love carried differently. A fear can remain real while no longer running the whole system. Forgetting and reconstruction are part of how the self stays capable of change. That may be one of the deepest reasons forgetting belongs within remembering. Without forgetting, the archive would become too rigid. Without remembering, the archive would become empty. The mind needs both. It needs traces that last and details that soften. It needs emotional marks and ordinary blur. It needs strong patterns, weak edges, useful habits, discarded clutter, revisited scenes, and released fragments. Out of that mixture comes something workable, something that lets a person continue. In a way, memory is less like a vault and more like a garden. Some things are cultivated, some return season after season, some die back and leave nutrients behind. Some seeds remain hidden for years until conditions are right. Some growth must be cut away so that other growth can continue. It is not neat, and it does not preserve every leaf. But it stays alive by selecting, pruning, strengthening, and adapting. Forgetting is one of the ways the garden keeps breathing. This perspective also changes how we might respond to everyday lapses. A forgotten detail is not always evidence that the mind is broken. Often it is evidence that the mind is prioritizing, compressing, or struggling under too much interference. Of course, there are times when memory problems reflect illness or serious change, and those deserve care. But much of ordinary forgetting belongs to the normal work of a brain that cannot and should not keep everything equally ready. Seen that way, the occasional lost word becomes less a catastrophe, and more a reminder that the system is selective by design, even if its selections are not always those you would have made yourself. There is something almost comforting about that design. It means the brain is not failing simply because it does not cling to every passing detail. It means the things that remain often remain for a reason, whether that reason is repetition, emotional force, meaning, skill, identity, or simple usefulness. It means that forgetting can make room for what matters most to stay more available. And it means that the story of a life is never just a pile of kept moments. It is also a shaped absence, a softening, a thinning, a letting go that allows the kept moments to become visible. So why does your brain remember some things and forget others? Because memory is not trying to make you into a perfect archive. It is trying to make you into a functioning human being. It is preserving what seems likely to help, what has been repeated, what was felt deeply, what fits into larger knowledge, what has become part of skill or self. It is releasing what seems less necessary, less used, less connected, or too costly to keep at the same strength forever. It is building a life out of emphasis, and perhaps that is the quiet truth beneath all of this. The mind does not honour the past by keeping everything. It honours the past by shaping it into something the present can live with. That is why a single sentence can survive decades while whole months fade. Why a smell can unlock a room you had not visited in years. Why your hands remember what your words do not. Why forgetting the exact detail does not always mean losing the lesson. Why memory can be so uneven and still so deeply meaningful. Right now, somewhere in your own selective archive, there are things bright as ever and things already softening. There are names you would know instantly, rooms you could still walk through in thought, skills your body would perform without discussion, and fragments you will not know you still carry until something small and unexpected brings them back. And while the mind continues its quiet sorting, keeping some, releasing others, building the self out of what remains, the story keeps moving gently onward.